Hi guys, assalamu alaikum. I hope you're all well and having a good day. So basically today we are back with another most common, difficult and important questions video. This time for the Edexcel levels physics unit 5. So without wasting any more time, let's start. Now this is a very important and common question. It says the penetration of nuclear radiation through materials depends upon the ionizing power of the radiation. As soon as I read this line, ionizing power, I should know that alpha particle has the highest ionizing power, right? A teacher tested an unknown radioactive source. He set up the source and a GM tube as shown. Just the thing I was saying that alpha particle has the highest ionizing power, but its penetration power is low, right? The initial count rate is determined without an observer between the GM tube and the source. When an aluminium sheet of thickness 0.5 centimeter was placed between the source and the GM cube, the count rate decreased to background level. So there was basically no count rate from the source. Okay, the teacher then removed the aluminium sheet and replaced it with a sheet of paper. There was no change in the initial count rate. So basically there was an initial count rate when there was a sheet of paper, but when there was aluminium sheet when there was an aluminium sheet, there was no background rate. The background, I mean, there was no count rate because the count rate decreased to the background level. So we can say there was no count rate. Here we can write no count rate, but here there was count rate when there was a sheet of paper only. Explain what type of radiation is emitted from the source. So we will have to guess what type of radiation was that, whether it was an alpha, beta or a gamma radiation. You should refer to the penetration of each type of radiation through each sheet of absorber. Now as they have asked us to refer to the penetration of each type of radiation. Now we know as alpha particles are highly ionizing, they have a low penetration power. Now as they have a low penetration power, they cannot even go through the sheet of paper. They cannot even go through the sheet of paper as well as the aluminium sheet. Okay, so basically we can say it wasn't alpha radiation because the radiation could go through the sheet of paper. That's why there was a count rate. There was a count rate because the radiation could go through the sheet of paper and reached the GM tube through the sheet of paper. Let's say this was the sheet of paper. So basically the radiation passed through the sheet of paper and reached the GM tube. So as it has passed through the sheet of paper and reached the GM tube, we can say it can go through the sheet of paper, and alpha radiation cannot go through the sheet of paper. It is absorbed by the sheet of paper. Okay, and talking about the gamma radiation can penetrate through the aluminium sheet. The gamma radiation can penetrate through the aluminium sheet, but here it couldn't penetrate through the aluminium sheet. Why? Because it has said there was zero, I mean the count rate decreased to background level. The count rate has decreased to background level. That means it couldn't penetrate the aluminium sheet and reach the GM tube. So that means it cannot be a gamma radiation as well. And if it is not a gamma radiation or an alpha radiation, then it is pretty much sure that it is an beta radiation. And here is the mark scheme points that you guys will have to be able to understand. Okay, it says alpha radiation would not pass through the sheet of paper because we know it is highly ionizing and its penetration power is very low. So there is no change in count rate when the sheet of paper is placed. That means the radiations are reaching the GM tube through the sheet of paper between the source and the GM tube. Therefore it cannot be an alpha radiation. Okay, now the next part says there cannot be any gamma radiation as well because the gamma radiation can pass through the aluminium sheet. Okay, and as it couldn't pass through the aluminium sheet, therefore it is definitely a beta radiation, right? So this is basically the 4 points that you guys will have to write to achieve the all the 4 marks. Now moving on to the next part of this question, it says the count rate R recorded after gamma radiation has passed through a thickness X of the lead is given by R is equals to R naught e to the power of minus mu x. Okay, where r naught is the count rate with no absorber present. So without basically the lead, the count rate is r naught. But when there is a lead, some of them will be penetrated and most of them won't be able to penetrate, right? And mu depends upon the energy of the gamma ray photons. All right. The graph below shows ln r with x for a particular source of gamma radiation. So basically, they have given us a graph of ln r. They have given us a graph of ln r. This is a very common question. The graph below shows how the value of mu depends upon the gamma photon energy. So basically this is the mu and how it actually depends upon the energy of the gamma photons. Now they have also given us some sources as their associated photon energy. So the photon energy of this source, the photon energy of this barium is given as well. Deduce which source was used for this investigation. So after reading all of these questions, it becomes really difficult to understand how should I approach the question. It becomes so difficult to understand how we should approach the question. Now the best possible way to approach this question is just going through the questions one by one. Okay, now let's have a look at the first graph. So at the first graph we have got that they have given us a graph of ln r against x. And we know here the equation was r is equals to r naught e to the power of mu by x. So basically the x is right here. And another thing that they have mentioned is the ln r. So basically we will have to learn this whole equation, the things that we have done in our physics unit 4, 5, even in unit 2 as well. So now let's do it right here. So basically ln r is equals to ln r naught plus ln e to the power of minus mu over x. So basically when we know r naught and e to the power of minus x is multiplied, right? And when they're multiplied in ln function we can add them actually. That's why we have written plus right here. So basically we know it can be written like this. We know ln e gets cancelled. We know ln e is equals to nothing, so we can write it like this. Ln r is equals to ln r naught, or we can write like this, ln r is equals to minus mu x plus ln r naught. We can write it like this. So basically this ln r is my y-axis, because in the graph you guys can see this ln r was my y-axis, right? So I can write it like this. This ln r is my y, this x is my x-axis. You guys can see they have drawn a graph x in the x-axis. So we can say this is my x, this is my y-intercept, and this mu is going to be my gradient. Okay, this mu is basically going to be my, sorry, my bad. So basically this mu is going to be my gradient, right? So the question that we were seeing right here was regarding deduce which source was used for this investigation. Now whether this source, or this source, to figure out which source was it, we will have to figure out the photon energy, and after figuring out the photon energy we can figure out the name of the source. And we know there is a graph of mu against photon energy. So to get the photon energy we'll have to figure out the corresponding mu value, and to figure out the mu value right here we can figure out the mu value right here by figuring out the gradient from this ln r against graph. So now let's figure out the gradient right here. We can take this whole line right from this position till this position to figure out our graph actually. We can take both of them to figure out our graph. Okay, we can take basically both of them to figure out our graph. Now if this is 500, this is going to be my 550, and this is going to be my 540. right? If this is 540, then if this is my 50, this particular value is going to be 60, right? This is going to be my 60. So we know this is my y2, this is my y1, the blue one, and this is my x1, which is 8, and my x2 is going to be this 0, right? Because this y2 corresponds with this x2, and this y2 corresponds with this x1, sorry, this y1 corresponds with this x1. So if this is my y2, this is my x2, and if this is my y1, this is my x1. So we know the formula of gradient is y2 minus y1 divided by x2 minus x1, and we know our y2 was 540 minus y1 was this value, which was 60, I mean this one right here, which was around 60, divided by x2 minus x1, and our x2 was 0 and our x1 was 8. So if we figure it out like this, we will get our value as just give me 1 minute to calculate. Our value is going to be actually minus 60 centimeter. So this is our value of mu. We know m is equals, this is the value of gradient, and we know m is minus mu. As it is minus mu, so we will make it 60. So basically our mu is going to, sorry for writing in the graph, we'll write it right here, that our mu is going to be 60, because mu is minus m. So mu is equals to 60. So we have got our mu value as 60. Now we will have to figure out the corresponding photon energy for mu, which is 60, right? So we know if this is 10, this is 20, this is 30, 40, 50, and 60. So basically this is my 60. So for this 60, let me figure this out 1 minute. So for this 60, we'll have to figure out the corresponding energy value, photon energy value. Now this corresponding photon energy value is 70 right here, because this is 80, this is 90, and this is 100. So this is 70. So our photon energy that we have figured out is 70. Now we'll have to choose the it is said deduce which source was used for this investigation. Now we will just use this 70 to figure that out. We know this photon energy is 120, it cannot be 360, it was around 70, so which is close to 80. So we can say our source was 113 xe. We can write it down like here. Photon energy is equals to 70 kilo electron volt. Never ever forget to write the units. Photon energy is equals to 70 kilo electron volt, and we have figured out mu is equals to 60 centimeter from the gradient. Okay, and don't write the gradient like me right here, write the gradient in this position right here. Okay, it is much better. So we can write so the source is 113 xe. You can write it down like this. Okay, so basically that's how you guys are going to do this type of maths, and this type of maths are quite common in recent question papers. So make sure you have understood each and everything in detail, and then try a couple of maths like this from the recent papers from Jan 2022 to Jan 2025. It will help you guys a lot. So make sure you are practicing some of them, okay, before your exam. The question number 15 says the Millennium Bridge as shown is a suspension bridge for people to cross the River Thames in London. The bridge developed a large swaying motion when people walked across. So swaying motion here is meaning that it oscillates when the people walked. When the people walks, it oscillates. dampers were fitted to the bridge to correct the swaying motion. We will have to understand the main objective of adding the dampers. The main objective of adding the dampers is it actually dissipates the energy by limiting the oscillation of the bridge. Explain the cause of the large swaying motion. So why does a large swaying motion actually occurs, and the effect of the dampers. So what actually the dampers does. So basically how the large swaying motion is caused. The large swaying motions means the large oscillation. A large oscillation means the bridge oscillating with a very high amplitude. Okay, why does it oscillates with a very high amplitude? The thing is, when the people actually walk, they set the bridge into oscillation, and that oscillation is called the driving. That oscillation actually has a driving frequency. Now if that driving frequency is equal to the natural frequency of the bridge also has a natural frequency, and when the people walk through the bridge is set into oscillation, and that oscillation has a driving frequency, and if that driving frequency is equal to the natural frequency of this bridge, then resonance occurs, and we know when resonance occurs, maximum energy transfer occurs, and when maximum energy is transferred to the bridge, it starts to oscillate with a very high amplitude, and then we use the dampers to reduce that amplitude of oscillation by dissipating the energy. So this is how the whole scenario works. This is a very common Edexcel levels physics unit 5 question that I think you should be able to answer. This is a star question. Now here is the answer that you guys should be writing like this to get all the 6 marks. Hopefully I was previously able to make you guys understand. Now it says when people walk, they set the bridge into oscillation with a driving frequency, and then resonance occurs because the driving frequency is equals to the natural frequency of the bridge, and there will be a maximum energy of transfer of energy to the bridge. When resonance occurs, there is a maximum transfer of energy, and when the maximum energy is transferred, the amplitude of oscillation of the bridge is maximum, and that energy is transferred from the bridge to the dampers, and when energy is transferred from the bridge to the dampers dissipate the energy and limits the amplitude of oscillation. So these are basically the 6 points that you guys will have to be able to understand and then memorize, because this is a star question and these questions are repeated again and again. Now let's moving on to the question number. A student investigated the relationship between the pressure and volume of a fixed mass of gas at constant temperature. So basically my temperature was constant, and as the mass was fixed, we can say the mass was constant as well. Now they were figuring out the relationship between the pressure and volume when the mass and the temperature was constant. So basically they have drawn a graph right here. The student stated that this graph demonstrated that the pressure exerted by the gas was inversely proportional to the volume occupied by the gas. So basically they are saying that pressure was inversely proportional to the volume. Okay, this is actually what the graph also shows, right? Assets the validity of the current of the student's statement. This is what they have said to assess the validity. Now we will have to actually show that both of them are inversely proportional from the graph. Okay, using the graph as they have given us a graph. Now there is a formula that we all know from our O levels, that is PV is equals to NKT, right? PV is equals to NKT. Now in this formula, the N is constant, right? The number of molecules is constant. The K is also constant as well. And here they have kept the temperature constant as well. Here the temperature was constant. So as the temperature was constant, we can say this as a whole is constant, right? This as a whole is constant. So we can say PV is equals to constant, and we know if P and V is in the same side, we can say pressure and volume are inversely proportional. Now if we calculate P into V from the graph, if we multiply any y value with its x value, with its corresponding x value, it should be a constant value that should be coming. Let's take 2 or 3 p and v values right here. Okay, let's take. Now if I take the p as 110 here, if I take the p value as 110, let's see what is the corresponding x value. Now the corresponding x value right here is basically 0.006, right? It is 0.006. So we can multiply both of them. That when pressure is 110, the volume is 0.006. So the value that comes is 660 Pascal meter cube. Now let's take another pressure volume and figure out its corresponding volume. Now if we take pressure as 600, sorry, if we take pressure as 60, now our corresponding volume value comes as 0.011. 0.011. So let's take this one, 60 into 0.011. So our value, the value comes as 660. So we can say in both the ways a constant value is coming here and here as well. The value is constant. Okay, the value is constant, and as pressure and volume is in the same side, we can say pressure is inversely proportional to the volume. According to the equation, they have also said that it was inversely proportional. So now we have shown two examples where the pressure has been constant. Okay, the multiplication of P and V gives us a constant value, just like we have figured out. So we can say the value of PV is constant, so the student's claim is valid. We can write it right here. The value of PV is constant, so the student's claim is valid. So writing this part is very important. It will give you the fourth mark, sorry. So as it is a 4-mark question, you guys will have to show all of these points. Okay, and you can also mention that you don't need to mention that as they have mentioned it already. So this is the thing that you guys will have to write to get all the 4 marks from this particular question. And this is another very common question that is more or less present in all Edexcel levels physics unit 5 papers. So make sure to do some of the more problems like this one. I will put another one actually, so that you guys can understand, or you guys can do them in a more easier way, inshallah. Today we will go through the gravitational potential and gravitational potential energies. Now you guys might ask me why you are showing us this thing just before the exam. The reason is there is a question regarding gravitational potential and gravitational potential energy, which is really common in our Edexcel physics unit 5. So before completing that question, we will complete and derive the formula that we will be using in order to solve that question. Right now, let's get started without wasting any more time and solve this type of a question. Let's say this is our Earth, okay, and this is the orbit at which a satellite will orbit the sun. A satellite will orbit the Earth in this. So let's say this is our satellite, and this is the orbital in which it will orbit the Earth. So if we write the center of the Earth, let's say this is the center of the Earth. From the center of the Earth, this is the radius. Let's say this is our R, which is the radius from the center of the Earth to the surface of the Earth. This is the surface of the Earth. This is the surface of the Earth, and this is the orbital. Let's say this is the orbit. Okay. Now, from the surface of the Earth, the satellite was at first in the surface of the Earth. This satellite was at first in the surface of the Earth, but then it was taken into a height h meter above the surface of the Earth. H meter above the surface of the Earth. So now it's around h meter above the surface of the Earth. This is h. So if we calculate the distance this satellite has gone is from the surface of the Earth is 1 r plus h. So that means it has gone a distance of r plus h. It has been taking to a distance of r plus h. So this blue line is r plus h. This is the distance, or this is the radius away from the earth. This is the radius the satellite is away from the earth. Now let's derive the formula of gravitational potential energy. We know del u means gravitational potential energy. Gravitational potential energy is gravitational potential into mass. So del v into mass, sorry, my word, del v into the mass. This is the formula of gravitational potential energy. Okay, gravitational potential into mass. Now the gravitational potential has a formula of minus gm by r into mass. This will be the formula. Now you guys might ask me right now, why the gravitational potential is negative right here? Why the gravitational potential is negative? The reason behind the gravitational potential to be negative is because at infinity, let's say it is at infinity. It is at infinity. And infinity we say gravitational potential is zero. At infinity, the gravitational potential or gravitational potential energy is zero at infinity. But the orbit at which the satellite will be orbiting is not at infinity, right? So it is not that much far away from the earth. So it is at negative potential. That's why it is at negative potential. This is the main reason behind it being at negative potential. Anything below the infinity part, anything below means anything in this part, anything in this part from the infinity is negative. If you can cross infinity or if you can reach infinity, at that time your potential will be zero. Before reaching the infinity, your potential or potential energy will always be a negative value. That's why it's a negative value. So let's now move forward and don't waste any more time. Now if I can derive the formula, u is equals to minus gm m by r by combining them two. Okay, now this is the formula. This is at the this is at the surface. This is the potential at the surface. This is the potential at the surface. This is the potential at the surface that we have derived right now. Now we have to draw for the orbit. Now we have to draw what is the potential, or what is the gravitational potential energy at the orbit. Now the gravitational potential energy at the orbit will be minus gmm divided by r plus h, because this h is also included, because you are r plus h radius away from the surface of the earth, from the center of the earth. That's why the formula will be like this. So this is the difference between them. Now we have to, if I have to change, or if I have to figure out, the change in gravitational potential energy of the satellite when it has moved from the center of the earth to the to this orbit, if I have to figure out the gravitational potential energy, if I have to figure out the change in gravitational potential energy as this satellite was first in this part and then later on move on to the orbit, what is the change in gravitational potential energy? The change in gravitational potential energy will be del u is equals to u final minus u initial. Now u final was at the orbit and u initial was at the center of the earth or at the surface of the earth. So u final is at the orbit, which is minus gmm by r plus h minus this value, minus gmm divided by r. So this minus minus becomes a positive value. So it is minus gmm divided by r plus h plus gmm by r. If we derive this formula and bring something into common, it becomes plus gmm by r minus gmm by r plus h. So this is the formula which will be really important for you guys today, because I'm more or less, I'm sure, or I think that this type of question will come today. So now as we have derived this formula and we have understood it completely, now let's go and solve a question together using this formula. Come on, let's go. in this question they have written what they have written. Let's go through the question right now again. They have written the dashed circle on the diagram represents gravitational equipotentials about the planet Mars. The gravitational potential at x and y is given. The gravitational potential at these 2 points are given. Meteor has a mass of 250 gram. Okay, this is an indication that we have to use the formula of gravitational potential energy. We know del V means gravitational potential is equals to GPE divided by mass. Okay, gravitational potential energy per unit mass is the gravitational potential. So they have asked in our question change in gravitational potential energy. So we can say our del GPE is equals to mass into del V. Okay, mass into del V. So they have asked which of the following is the change in potential energy as meteor falls from y to x. So at y and x, so we have to minus these two gravitational potential energy. So first of all, we can figure out the gravitational potential energies, which is given as gravitational potential of this. So what we can do is they have the same mass, but the v is different. This v is different. One is this and the one is this. So what we can do is we can write del gp is equals to mass of del v means, let's say, x minus y. Del v means the potential at x minus y. So we can write it down as x minus y. So here m into minus 5.5 m gel minus 3.7 mg. We can write it down like this, and this mass will be 250. So 250, it will become 250 into minus 1.8 milli per kg. So the answer will come out as minus 450. So our correct answer will be this. The correct answer will be C. Here at actually it will not be y minus x, it will actually be x minus y. My bad. It will not be x minus y, it will be y minus x, because y is at greater potential. Y minus x. So minus 5.5 joule minus 3.7 joule. So this is how we will do them. Okay. Right now we have got minus 450. And now another thing that I want to make you guys understand, though it is not written in our question, but I still want to make you guys understand, is why is this gravitational potential energy negative? The gravitational potential energy is negative because the gravitational potential at point x is more negative or at a lower point than y. It is at a lower point than y. That's why it is more negative, meaning the meteor is moving to a region of stronger gravitational potential, means closer to the planet's surface. This indicates that a meteor is losing potential energy as it falls. It is losing the potential energy as it falls. Since the meteor is moving towards a lower potential, it has a lower potential than it. This loss of potential energy is represented by negative value. As it has a higher potential and it has a lower potential, the meteor is moving from a higher potential to a lower potential. So this loss of potential is shown by the loss of potential energy, which is represented by a negative value. That's why it is important to understand why the gravitational potential energy is negative. That's why the negative sign reflects the decrease in gravitational potential energy as the meteor falls towards the planet. It is moving from a higher potential to a lower potential. So its gravitational potential energy is decreasing as it is going from a higher potential to a lower potential. That's why we are showing gravitational potential energy by as negative sign, as the gravitational potential energy is negative because it is coming from a higher potential to a lower potential. Done. Right. In this question number 4, they have written a satellite of mass m is on the earth's surface. Okay, very good. A satellite is moved into a circular orbit of h above the earth. Okay, so let's say this is the earth, this is the center, and the satellite was at this position at first, which is 1r, and after that it was moved to a height of h. It was moved to a height of h above the earth's surface, above the earth. Okay, the mass of earth is m and the radius of earth is r. Okay, which of the following gives the change in gravitational potential of the satellite? the change in gravitational potential energy of the satellite when this satellite was moved from this position to this position. Okay, what is the change in gravitational potential energy? We know gravitational potential energy, the formula of gravitational potential energy is, U is equals to minus GMM by R. This is the formula, right? This is the formula of change in gravitational potential energy. Okay. Now, I'm not going to derive this formula today. I'm not going to derive because this derivation is very basic and it is in your book. If you haven't learned this derivation, then please go to your book and learn the derivation, or go to your notes that you have studied. And the other thing is, if you haven't learned the derivation, please let me know in the comment box. I will make a separate video for derivation. Now we know gravitational potential energy is equals to minus gm by r, and now some students have a question why there is a negative sign right here. I'm going to explain that thing. Okay, the gp is negative here. The gp is negative because gravitational forces are attractive. The gravitational forces are attractive, and the reference point u is 0 is taken at infinity. Let's say at here in the infinity the u is 0, and if the at infinity the u is 0, then anywhere between here or even here the gp will be negative. The u is 0 is at infinity. Let's say it is an infinity at very, infinity means it is very away from the center of the earth. At infinity the gravitational potential energy is 0, but anywhere in between the infinity and the earth's surface the gravitational potential energy is said to be negative. That's why we have put a negative sign right here. So in this position at the surface, we can say in this position the gp is said to be u is equals to minus gm m by r, right, in this position. But when it was taken into height h, at that time the gravitational potential energy will be minus gmm by not this radius, because now the radius is with this r, now the radius is along this r plus this height, so it is r plus h. This is the value, right? Now if we have to find the change in gravitational potential energy, this is the gravitational potential energy at the surface of the earth, and it is the gravitational potential energy at the height h to which this satellite was moved. Now if we have to find the change in gravitational potential energy, we have to subtract the final value with the initial value. Now what we can do is minus gmm by r plus h minus gmm by r. So this minus minus becomes a positive value, so minus gmm by r plus h plus gmm by r. So what we will do right now is we will write it plus gmm by r minus gmm by r plus h. So basically this is our correct answer, B. This is how we will derive the question. Now let's have a look at one example question. It says Mech is a dwarf planet in the solar system. Mech has a mass of 3.1 to 10 to the power 21 kg and a radius. So basically they have given us the mass and radius. They have asked us to figure out the gravitational field strength. We know the formula of gravitational field strength is G is equals to gm by r squared, right? This is the formula. Now the bigger G is a constant, which is 6.67 into 10 to the power minus 11 multiplied by the m, which is the mass of the Mech, which is going to be 3.1 into 10 to the power 21 divided by the r squared. They have given us the radius as 715, so we will basically have to convert it into meters. Okay, so 715 into 1000 squared. This will give us a value of 0.404 Newton kilogram minus 1, and we will give our answer as 0.40 in two significant figure, because the least value that they have given us in the data is two significant figure. Now the next part, this is the difficult question. This is the type of question we were looking at. So it says the average distance of Mech from the sun is similar to the average distance of the dwarf planet Pluto from the sun. A website states the time taken by Makemake to complete one orbit of the sun is 20% greater than the time taken by Pluto to complete one orbit of the sun. So someone is bigger than the other one. Someone is bigger than the other ones. The time taken by someone is greater than the other ones. So this type of questions are very common in physics unit 5. This is a one type of question that was right there in the Jan 2025 paper as well. I will upload this paper within 1 or 2 days, so please subscribe to our YouTube channel to get that video. So there I will also explain the same thing. So basically now let's have a look at this question, how to solve this one. So basically the time taken by Makemake was 20% greater than the time taken by Pluto, right? So orbit time of Pluto is given. They have given us the time taken by the Pluto as 248 hours. Now we will have to calculate the time taken by Makemake, and after we are done with calculating the time taken by Makemake, we'll be able to see whether it is actually 20% greater or not, right? So first of all, we have to figure out the time taken by Makemake. So we know there is a formula. Angular velocity is equals to 2 pi by time taken. As they will be orbiting, they will be moving at an angle, and we know we'll have to figure the angular velocity, which is 2 pi by time taken. So to figure out the time taken of this rotation or orbit, we'll have to know the angular velocity first. So we will first calculate the angular velocity. Okay, now let's have a go at it and let's figure out the angular velocity. Now one thing that we'll also have to understand is, let's draw like this. Let's say this is the sun, and here the Makemake is going to orbit around the sun. Okay, let's say here the Makemake is going to orbit around the sun. So as the Makemake is going to orbit around the sun, okay, the Makemake, let's say this is the Makemake and this is the sun. I'm sorry, this one is like this, and let's say this is my Makemake and this is my sun. So basically when the Makemake will be orbiting around the sun, it will be moving in a circular motion, and from physics unit 4 we know when something is moving in a circular motion, there is definitely a centripetal force acting, right? There is definitely a centripetal force acting towards the center of the circle. Towards the center of the circle there is a centripetal force acting. So who is exactly exerting the centripetal force right here? We know the sun does have a mass, so does the Makemake. So as both of them has a mass, so basically the sun will be exerting a gravitational force on the Makemake, and the Makemake will also be exerting a gravitational force on the sun. So basically as the sun is exerting a gravitational force on the Makemake, the gravitational force exerted by the sun on the Makemake will be in this direction. Okay, it will be in this direction, and this gravitational force is going to be the actual centripetal force, because the sun will be exerting a force on the Makemake in this direction, and there must be a perpendicular force to the direction of motion of the Makemake to be able to move in a circular motion by the Makemake, as it is orbiting the sun. So there must be a centripetal force, and this centripetal force is exerted by the sun on the Makemake as a form of the gravitational force. So we know the formula of gravitational force is, we can say that gravitational force is equals to the centripetal force, right? So gravitational force is equals to the centripetal force. So the gravitational force is going to be right here, gmm by r squared, which is equals to mr omega squared, right? Now we'll have to figure out the angular velocity, right? This is going to be our subject. So if we make angular velocity as a subject, so it becomes w is equals to gmm divided by the r cube. Gmm divided by the r cube. So now let's do this math. 6.67 into 10 to the power minus 11 multiplied by the bigger mass. Sorry, one thing that we'll have to understand is this is not going to be gmm, my bad, extremely sorry for that. This is going to be gm, okay, because the reason is this mass and this mass will be cancelled out. So 6.67 to 10 to the power minus 11 into 1.99 into 10 to the power 30, which is the mass of the Makemake, divided by, sorry, which is the mass of the sun, because this m is the bigger m and this is the smaller m. So this smaller m is the mass of the Makemake, and this bigger m is the mass of the sun. this m is always the mass of that uh, particular object which is exerting the gravitational force. Okay, so it is 6.67 into 10 to the power minus 11 into 1.99 into 10 to the power 30 divided by the r cube, and we know the orbital radius of Mach is 6.8 into 10 to the power 12 that they have given us. So let's use that right here. So it is going to be 6.8 into 10 to the power 12 cube. So the answer will be 6.5 into 10 to the power minus 10 radian per second. We have calculated our angular velocity. Now we will have to just figure out the time period by dividing 2 pi by angular velocity. So time period is equals to 2 pi by angular velocity. So now time period is equals to 2 pi by angular velocity, and when we know we have figured out the angular velocity previously, so it will be 6.5 into 10 to the power minus 10. So our time period's value will be 9.67 into 10 to the power 9 seconds. We have successfully figured out our time period, but the time period value right here is in seconds, and in the question they have asked us basically this is the time it takes for the Mach to complete one orbit, right? Or basically we can say the orbital time of Mach is this, but this value is in seconds. But here in the question we will have to compare the orbital time of the Mach with the orbital time of the Pluto, and they were saying that the orbital time of the Mach was 20% greater than the orbital time of the Pluto. So to compare, now they have given us the orbital time of Pluto in years. So as they have given us in years, so to be able to compare, we will have to convert the orbital time of Mach as well into years. Okay, so now this is given in seconds, so we'll have to convert them into years. So we know for the orbital time of Pluto is 248 years, and the 1 year is equals to this seconds. Now if 1 year, let's say if let's like you can use unitary method, if 3.15 into 10 to the power 7 is 1 year, then 1 second will be equal to 1 divided by 3.15 into 10 to the power 7, right? And this much of seconds will be equal to, I mean 9.67 into 10 to the power 9 will be equal to 1 divided by 3.15 into 10 to the power 7 multiplied by 9.69 into 10 to the power 9. So this is basically how we will do this, right? So it will give us a value of 307. Now we have got that 307 years is the time that Mach take to orbit the sun, right? So now we have got the orbital time of Mach. Now we will compare it with the orbital time of Pluto to see whether it is 20% greater or not. This is the Mach value, so we will take this Mach value, subtract it by the Pluto value, which was maybe 248 divided by 248 into 100%. So we'll get, yes, the value is 24%. So we can say yes, the orbital time of Mach is 24%, or actually 20% greater than, or is 20% greater than the time taken for the Pluto to complete one orbit. So we can say, so yes, the statement is correct, as it takes 24% more time for Mach to complete the orbit. So that's how we can actually write it down. In January 2023, the asteroid 2023 BU came close to the Earth. The closest distance of the asteroid from the surface of the Earth was 3590 km. Alright, calculate the forces between the asteroid and the Earth at this closest distance. You may assume that the asteroid is a sphere. So they have said that it is a sphere. So basically the forces that will be acting between the asteroid and the Earth, and we know when the two masses are close to each other, the only force that is acting on each other is the gravitational force. Each other exerts gravitational force on each other, right? So basically we can write the formula F is equals to gmm by r squared, right? This is going to the formula that we will be using for this particular math. Now to figure out the force, we know force is equals to g. The g value is 6.67 into 10 to the power minus 11 multiplied by the bigger mass. The bigger mass is going to the mass of the earth, which is 5.98 into 10 to the power 24 multiplied by the mass of the asteroid. Now we don't have the mass of the asteroid. Let's write the radius. Let's write the r. So basically this is the r squared. So now the question arises, which r we are going to actually take. 6380 into 10 to the power 3, because we'll have to convert it into meter, plus this 3590 into 10 to the power 3. Now you guys might ask me, why did I add both of this? The reason behind adding both of them we have discussed previously, right? Now still I will show you guys, because this is a little bit tricky. Let's think it of the earth, and let's think that this is my asteroid. Okay, so basically they have said the radius, they have said 3590 kilometer was from the surface of the earth. So this is the distance of the asteroid from the earth. This is 3590. But we will not take this value only, we will also take the distance from the radius as well. We will take the distance from the center. So this radius was 6380. That's why we have added both of them, because we will have to take the distance of the asteroid from the center of the earth. That's why we have added both of them. Now there is also another question that remains, is how to calculate the mass of the asteroid, that we didn't calculate yet. So basically they have given us a hint right here. The hint is that they have given us that asteroid is a spherical object, and we know in a spherical object the volume is 4 by 3 pi r cube. Now you guys might ask me, why did I bring in volume right here? Because they have given us the density. So you guys will have to use this density as well as this volume to calculate the mass. We know density is equals to mass by volume, right? So here 4 by 3 pi into radius cube. And they have given us the diameter of the asteroid. So we can say 5.65 divided by 2 into cube, 4 by 3 pi r cube. This will, we know density is equals to mass by volume. So mass is going to be density into volume. So this was my volume multiplied by density. My density is 1950 multiplied with 1950 will give me my mass, and this value will be 1.842 into 10 to the power 5 kilograms. So I will put it right here, 1.842 into 10 to the power 5. So putting all of these values, we will get our answer as 7.39 into 10 to the power 5 Newton. Now the question remains, why did I add both the radius? I have explained it, right? We will have to take the distance of the asteroid not from the surface of the earth. We will have to take the distance from the center of the earth. So we have given the surface of the earth, the distance is 3590 here from the surface of the earth. So we will have to also take the radius into consideration, something that I have shown you previously before starting this gravitational field chapter, right? Now the next question says, calculate the change in gravitational potential energy of the asteroid if it had fallen to the surface of the earth from a height of 3590. So it will fall to the surface of the earth from a height of 3590. So it is falling to the surface of the earth from a height of this value. So let's draw this again. This is my earth and this is my asteroid. So here the distance is 3590. Here the distance is 3590, and here from the center, I have drawn this line a little bit angularly. Give me a little bit of time, guys. So basically this is the distance from the surface of the earth to the asteroid, right? The distance of the earth from the asteroid, the distance of the earth from the surface of the earth. We'll also have to take this value into consideration, the radius. We'll also take the radius into consideration, though the line has been not correct. So this is basically my radius, right? This small part is my radius, and this small part is the height from the surface of the earth to the asteroid. So now they have said that it has fallen and now it is in the surface of the earth. Previously it was 3590 kilometer away. Now it is in the surface of the earth. So how does the potential energy changes? How does the potential energy changes? And we know one thing, that potential energy is equals to, sorry, potential is equals to gravitational potential energy per unit mass. We know V grav is equals to gravitational energy divided by mass, right? And now they have asked us to calculate this gravitational energy. So before calculating this gravitational energy, we'll have to calculate the potential, and then we will multiply it with the mass. So it has a potential right here, and then it will also have a potential right here. So the change in potential between these points is something that we'll have to figure out, and then we will multiply it with mass to get the change in gravitational potential energy. So we know the potential of the asteroid right here is minus gm by r plus h, and the potential right here at the surface will be minus gm by r, right? Now if we multiply mass with both of them, this mass, it will become like this and like this. We have multiplied the mass with both of them. Now we know it has fallen. It has fallen. So it has fallen from a higher position to a lower position. To figure out the change in potential, we'll have to subtract from this value. We'll have to subtract this value and this value. So we'll subtract the initial value from the final, right? To figure the change in something, we'll have to minus final minus initial, right? So this was the final value, so it has fallen, and it was the initial. So final minus initial, so it will become minus gmm by r minus gmm by r plus h. So this formula can be written as minus gmm by r plus gmm by r plus h. This is how this particular formula can be written down, right? Now we can actually see that minus gmm is common in both the parts, so we can take that common. Okay, so to take that common, we will write minus gmm, okay, into 1 by r minus 1 by r plus h. I have taken this one, okay, this minus and this minus. So this is how it looks. So this minus minus becomes plus like this. So don't worry about that part. So now we can write minus 6.67 into 10 to the power minus 11 into 1.842 into 10 to the power 5, which is the bigger m, multiplied with the smaller m is 5.98 into 10 to the power 24. This was the mass of the earth, and the smaller mass of the asteroid was this that we have figured out. Where is that? Yes, this is the 1.842 into 10 to the power 5. This one was the smaller m, and this one is the bigger m. 1 divided by this radius, the only radius, this radius only. So the radius of the earth is 6380. So we can write it down like this: 6380 into 10 to the power 3 minus 1 divided by 63, just 1 minute, 6380 into 10 to the power 3 plus the height from the surface of the earth to the asteroid, which is 3590 into 10 to the power 3. So this is all the maths that we have done. After putting all of this into your calculator, you will be able to figure out the value of this gravitational potential energy, as our E grav value will be equal to minus 4 point, let's write it down right here. Our E grav will be equal to minus 4.14 into 10 to the power 12 joule. So this is my gravitational potential energy, and we have multiplied this mass with the gravitational potential right here in both the parts. So that's how you guys will have to be able to do this type of maths. Now moving on to the next. Explain why the mass of the asteroid would not remain constant as the asteroid fell to the surface of the earth. So basically let's think it of like this. This is the earth and this is the asteroid. So when the asteroid is coming or falling to the earth, its motion is downward, and we know friction always acts opposite to the direction of motion. So the friction will be acting in the opposite direction. So as the frictional force will be acting on the asteroid, okay, so we can say work will be done by the frictional force on the asteroid. So when the friction acts, this friction causes heating of the asteroid, and the asteroid will burn up. And when the asteroid burns up, some of the gas and dusts also burns up. So those gas and dust will be lost, and when the asteroid will burn up, some of its mass will turn into gas and dust. So its mass decreases when it is falling, because some of the dust and gas will be left behind. So this is going to be our answer, that work done by the frictional force on the asteroid, and friction causes the heating of the asteroid, so some of its material turns into gas and dust that gets left behind. So the mass of the asteroid decreases when the asteroid burns up. This is the perfect 2 marks answer. Though I have written 3 points, it's very important to understand each and every point. The Earth takes 365 days to make one complete orbit of the Sun. Alright, we all know that. Show that the mass of the Sun is about 2 into 10 to the power 30 kg. So they are asking us to figure out the mass of the Sun. Radius of the Earth's orbit about the Sun is this. And they have also given us the time in seconds of 1 year. Alright, so basically one formula that we all know is force is equals to gmm by r squared. Right, force is equals to gmm by r squared. Now you guys might ask me, why am I bringing this mass or this force formula right here? The question has asked me to figure out the mass of the Sun, and why did I bring out the force? The reason is because the Sun has a mass, so does the Earth. So as both of them has the mass, both of them will be exerting gravitational force on each other, right? We know, let's say this is the Earth, and let's say this is the Sun actually, okay, and this is basically the Earth. So so the Earth is actually revolving around the Sun, right? The Earth is actually revolving around the Sun. So when the Earth is actually revolving around the Sun, when the Earth is actually revolving around the Sun, a gravitational force is exerted by the Sun on the Earth and by the Earth on the Sun. So let's talk about the gravitational force exerted by the Sun on the Earth. So this is basically my Sun and this is my Earth. So basically the Sun is exerting a gravitational force on the Earth in this direction. Let's try it like this. It is exerting a force in this direction, and we know as the Earth is orbiting the Sun, it is moving in a circular motion. It is having a circular motion, right? And there must be a centripetal force acting on it, and that centripetal force is exerted by the Sun on the Earth in the form of the gravitational force. So we know the formula of centripetal force. The formula of centripetal force is gonna be mr omega squared right here. The formula of the centripetal force is gonna be mr omega squared right here. And we know the centripetal force right here is actually the gravitational force, right? The gravitational force and the centripetal force. So we can write both of this formula as a whole. So we can write mr omega squared is equals to gmm by r squared. Out of this we will have to just make this m the subject, because this m is the mass of the sun. Okay, this mass is the m of the sun, and we can cancel out both of these small m. So our formula will become m is equals to r cube into omega squared divided by the bigger g. So we know we'll have to figure out the angular velocity first to do this math. So how can we actually figure out the angular velocity? We know the formula of angular velocity is equals to 2 pi divided by time taken, and we know the time in seconds, right? We can write 2 pi divided by, and we will get the value of angular velocity as 1.99 into 10 to the power minus 7 radian per second. So we will basically put this value right here in the angular velocity portion. Okay, so basically to get the m, we will write m is equals to, they have given us the radius, right? Did they give us the radius? Yes, they have given us the radius. So we will write 1.49 into 10 to the power 11 cube multiplied by 1.99 into 10 to the power minus 7 squared divided by the g, and we know the value of g is 6.67 into 10 to the power minus 11, which will give us a value of m as 1.96 into 10 to the power 30 kg, which is basically the value that they have asked us to show. We can write the answer as 2 into 10 to the power 30. So basically this is going to be our final answer. Now moving on to the part B, it says a television program channel claimed that the gravitational field strength at the surface of the sun is 28 times the gravitational field strength at the surface of the earth. Deduce whether this claim is correct. Now this question is a very common question. This type of questions are generally asked in Gen 20 in every physics unit 5 sessions. If you want, you can watch my October 24 and May 24 paper solving videos as well, which I'll be providing in the description box, as well as the prediction video of the Gen 2025 exam and multiple choice questions videos for the Gen 2025 exams. All of the physics unit 5 videos that I have made, I'll be providing in the description box so that you guys can watch and know about the trends of the questions that are actually coming in the exam. And the most recent 3 papers, the May 24, October 24 and this Jan 25 paper, will be uploaded in my YouTube channel. You can watch in the description box. I will be providing in the description box. Now let's jump on this question. It says someone is bigger than the other one. When someone is bigger than the other one, the best possible way to show that, yes, if it's saying that sun is 8 times greater, right? Sun is actually 28 times greater. The best possible way, how is it greater? Its gravitational field strength is greater than the gravitational field strength of the earth. So basically we will have to compare between the gravitational field strengths. So basically we know the gravitational field strength at the surface of the earth, right, which is 9.81. Now we will just have to figure out gravitational field strength of the sun and see whether it is 28 times greater than 9.81 or not. So to figure that out, before we will write the formula, it says 28 times. Someone is 28 times greater than the other one. So our first approach will be to divide the gravitational field strength of the bigger one, which is greater, divided by the gravitational field strength of the earth. We know the gravitational field strength of the earth is 9.81, and we will figure out the gravitational field strength of the sun and divide it by 9.81, and we will see whether it is 28 times or not. So now let's figure out the gravitational field strength of the sun. So we know to figure out the gravitational field strength, there is a very easy formula, which is gm by r squared, right? And we know g is 6.67 into 10 to the power minus 11 multiplied by the mass of the sun that we have figured out previously, which was 1.96 into 10 to the power 30 divided by the r squared, and we know the radius, right? We know the radius of the sun that they have given us. they have given us the diameter. Actually, we will divide it by 2 and then we will square it. So it will be 1.39 into 10 to the power 9 divided by 2, and then we will square this value. So by doing this, we'll get the value of the gravitational field strength of the sun as 270.7 Newton per kg. Sorry for my bad handwriting. So we'll put it right here and see whether dividing this one will get us this value or not. So 270.7. Whenever there is a bigger value, always put the bigger value in the numerator and the smaller value in the denominator to see whether it is that times bigger or not. So we will see that yes, it is 27.6. The value comes as 27.6. So we can say yes, the calculated value is consistent. Yes, it is 28 times 28 times 28 times the gravitational field strength of the earth. Don't write it like this, always write the full writing. I'm writing it like this. You're in, so the claim is correct. You should write the whole writing right here, that the gravitational field strength, okay, of the earth. Don't write simply like me. I'm just writing it like this to save time and not to make the video big so that it doesn't get exhausting for you guys to watch the whole video. Now this is a very important question in which students faced a lot of issues. Now let's have a look at this. It says the capsule was found after 14 days. Calculate the total energy in joule released from the capsule in 14 days. So basically this capsule was inside someone's body and it was found after 14 days. So now it is asking how much energy this capsule has released in that particular person's body in that 14 days. The activity has been given and energy released in each decay has been given. So as they have given us energy released in each decay, we'll have to take into consideration how much decay happened in that capsule in those 14 days will give us the total energy released by that particle, right? So to figure out that, you have to use this activity. We know the formula of activity is number of atoms decayed per unit second. So as it is 19 gigabecquerel, we can say 19 gigabecquerel numbers of atoms decayed every second. So it becomes 19 gigabecquerel is the activity. We know activity is the rate of decay. So in 1 second, actually 19 gigabecquerels of atoms decayed, and in each decay it released an energy of 1.17, and it happened for 14 days, not only 1 second. So we'll have to take into consideration how many seconds for which it acted. So it was for 14 days. So if in 1 second it released 19 gigabecquerels of atoms, then in 14 days how much did it release? And if 19 gigabecquerel was released, is the number of atoms released. Now in each atom how much the energy was released, we'll have to take into that consideration as well. So total energy is equals to 19 into 10 to the power 9 into 19 into 10 to the power 9 becquerels. This is the number of atoms that decayed, and this was the number of atoms decayed per second. So we'll have to take in consideration how much atoms decayed in 14 days. So it will be 14 into this 86400. Using this, we will get the value of how much atoms actually decayed in those 14 days. And to figure the total energy released by this huge amount of atoms decays will be figured out by this, because we know if one atom decay, it releases this much amount of energy. Now for this huge amount of decays, how much energy will be released will be figured out by multiplying it with 1.17 mega electron volt. And they have asked us our answer to be in joule. So as our answer needs to be in joule, so we'll have to convert this mega electron volt into joule as well. So how we will convert it? We will multiply it with 10 to the we will multiply it with 10 to the power 6 for the mega, and for electron volt it will be 1.6 into 10 to the power minus 19. This will give us the value that we are looking for. And our value will be 4.30 into 10 to the power 3 joule. Now basically this concepts was a bit difficult to understand. Not concept actually, the formula was a bit difficult to understand. If I explain it again, now as we have got our activity as 19 becquerels, right? They have given us activity as 19 gigabecquerels. So we have written that activity, and we know the activity means the rate of decay. So as it is the rate of decay, let's say as the activity of 19 gigabecquerel, we can think it of like this, that there was 19 gigabecquerels of decays every second. So in 1 second there was 19 gigabecquerels of decays happening. So we have got the number of decays in 1 second. This was the number of decays in 1 second, but the question asks us to do it for 14 days. So we have multiplied the number of seconds in those 14 days with the number of decays in 1 second. So here, after multiplying both of them, we have got the number of decays in 14 days. Now as we have got the number of decays in 14 days, the question was about the total energy. So to get the total energy, we'll have to multiply the total number of decays with the energy released in one decay. So this was basically the total number of decays happening in 14 days, and basically this 1.178 on the power 6 is the energy released for one decay. So we have multiplied both of them, and we are not going to take 1.17 mega electron volt. We'll have to convert them into joule, because the final answer needs to be in joule as they have mentioned it right here. So that's how you guys will have to understand each and everything. And this, I'm not gonna say that this writing this formula was easy. It was a bit tricky, but yeah, this kind of things are always common. So make sure you are paying attention while doing this type of questions. Now let's move on to another tricky and common question before your exam tomorrow. So let's read this question and do it. Okay, so air is used to inflate a balloon. The inflated balloon has a volume and contains this number of particles, and it has a volume of this. Okay, this has a pressure of this, and they have asked us to find the average kinetic energy of the molecules. When they will say average kinetic energy, we will straight jump onto one equation or one formula, which is half mc squared is equals to 3 by 2 kt. This is the formula. Now they have asked us to find the average kinetic energy. So we know half mc squared is our average kinetic energy. So we can write it down as average kinetic energy is equals to 3 by 2 kt. This half mc squared is our kinetic energy. So we can say kinetic energy is equals to 3 by 2 kt. This is average kinetic energy, my bad. Average kinetic energy is equals to 3 by 2 kt. Now we know 3 by 2 k is a constant. Now we just have to find out the temperature in Kelvin, which will give us the average kinetic energy. Now in order to find the temperature, we have to use the formula PV is equals to nkt. This is the formula which we will have to use. In this PV is equals to nkt, nk is a constant, so we can remove that part because it will not change the value. Okay, actually k is the constant which we don't need to take into consideration, but we can write this formula like this, that temperature will be equal to PV by nk. Okay, we have got the pressure as 1.15 into 10 to the power 5 into volume as 1.77 into 10 to the power minus 3 divided by the nk. We have got the n as well, which is 5.15 into 10 to the power 22 into the k value. The k value is constant, which you need to memorize, or you can find it in the last part of the question paper, minus 20 by 3. So this is how we will get our temperature. Our temperature will be 286 Kelvin. Now we can use this temperature value to put right here to get the average kinetic energy. So 3 by 2 into k is 1.38 into 10 to the power minus 23 into this 266 Kelvin will give us our average kinetic energy. So the average kinetic energy will be 5.93 into 10 to the power minus 21. So now we are done with this question as well. Now let's move forward to another question relating to this formula, which is highly important for your exam in the January 2025 and May 2025, because these type of questions are very common, and it may come because it came in the October 24 paper as well. All right, so let's start solving the question number 11. Helium gas can be used to fill balloons. Okay. The cylinder of helium gas contains this number of molecules. Okay, this is the number of molecules. Number of molecules. The temperature of the gas is 293 Kelvin. Okay, calculate the internal energy of the helium gas. So this is quite a different type of question, which wasn't that much common in the previous question papers. It's a very different question to the ones that always come in our physics unit 5. So October 2024, this is a different question, and for the January 2025 candidates, this question will be really easy, and I will suggest you guys to revise page number 123 to 124, these two page from the physics student book, 123 and 124, because that will be very important to understand this internal energy part. Though this question is just a 2 marks question, but you never know, maybe in the January 2025 or May 25 session this question might be a handy question, or a bigger question might come from this concept, which I hope you guys, I am more or less sure that you guys are not familiar with, because these type of questions are not that much um, common in our unit 5. So let's solve this question. They have asked about the internal energy. And we know there is only one formula which relates the internal energy. That is half mc squared is equals to 3 by 2 kt. The formula is half mc squared is equals to 3 by 2 kt. This is the formula. If I break down this formula, we know the average kinetic energy of any molecule in a gaseous sample. So they are talking about the internal energy of the helium gas. So they are talking about the internal energy in a gaseous sample. So the average kinetic energy means half mc squared of any molecule, of one molecule. We are talking about one molecule, is proportional to the absolute temperature of the gas. So this is basically talking about the temperature, and this is the average kinetic energy of one molecule. Okay, this is the temperature of one molecule, average kinetic energy of one molecule. So this is going to be our internal energy as well, because we are talking about not only one molecule, we are talking about 1.2 into 10 to the power 24 molecules. So if for one molecule the formula is 3 by 2 kt, then for this number of molecules it will be 3 by 2 kt into 1.20 into 10 to the power 24 molecules, because this formula is for only one molecule, and this you need to multiply it with this number of molecules. So it will be 3.2 into k is, what is the value of k? You guys need to memorize the value of k, because it is really important to be able to remember them. Okay, it's very important to memorize the value of k. 1.38 into 10 to the power minus 23 into 293 Kelvin. This is the temperature T. The overall value comes as 7280 joule. You can also write it down as 7300 joule. So basically this is our correct answer. So we are done with it. Okay, so the internal energy means the energy of this number of molecules, or the kinetic energy of this number of molecules in a helium gas. This is the kinetic energy of one molecule. So we have this number of molecules, so the overall kinetic energies added together will be the internal energy. Okay, so basically we are done with the question number 11. This is a very important question. I tried my best in order to make you guys understand, but still it is very important to understand the RMS speed, which is root mean square speed, and Maxwell Boltzmann distribution graph as well. So make sure you are reading page number 123 and 124. This is internal energy part, exercise 8A from your physics student book 2. Please read that. Otherwise, you will be in big trouble in January 2025 or May 25, because I'm pretty much sure that there will be a question regarding this. Alright, so this is a thermal physics question which is more or less present in every physics unit 5 exam. So let's solve this question with a lot of determination. Now, what we can learn from this is, we can say, um, let's say here I have taken a cold water. In this box there is cold water, okay? So what I will do is, I will pour some hot water into this cold water. I will pour some hot water into this cold water. Let's say um, I will pour some hot water into this cold water. So as I am pouring hot water into this cold water, the temperature of this cold water will decrease, right? No, the temperature of the cold water will not decrease, my bad. The temperature of the cold water will increase and the temperature of hot water will decrease, because at first, let's say it was 85 degrees Celsius and it was minus 5 degrees Celsius. So when these two will mix, the cold water will become, let's say, 40 degrees Celsius, and it will decrease down to 40 degrees Celsius. So we can say the temperature of hot water is decreasing and the temperature of the cold water is increasing. This is what will happen. Okay, this is what it will happen. Let's say this is not a cold water. Let's say this is an ice. Let's say this was an ice. If this was an ice, then what will happen is, this hot water's temperature will decrease and this ice temperature will increase. But when the temperature of the ice will increase, the temperature of the ice will increase, first of all, before increasing the temperature of the ice will melt first. The ice will melt at first. After melting, then when it will become a liquid, at that time its temperature will increase. At that time its temperature will increase. So while writing this type of answers, our first thing is, we have to write one thing. That is, the first thing that is happening is, let's say the energy is transferred from the cooling, right? Energy transfer from hot water is equals to energy transfer to melt ice plus energy transfer to heat the ice water, right? This is the thing. The first thing, let's say here is a cold ice and here is some hot waters that we will pour in this. So what will this hot water do? The hot water's temperature will decrease and the ice temperature will increase. So as the hot water is poured into the ice will first melt. You cannot increase the temperature of the ice, right? There is no hot ice, there is hot water. Ice cannot be hot. So first this ice needs to convert it into water. So doing we are melting it. So this energy is transferred to melt the ice. That's why the energy transfer from hot water means this hot water's temperature is decreasing. So where is this energy going? This energy is using in order to melt the ice, and then after melting the ice we will increase the temperature of the ice. That's why how the formula is derived. I will do two maths for this type of question. Now let's read the question and solve it. They have said the 325 gram of hot water at 85 degrees Celsius is poured into a polystyrene cup bearing containing of 62.5 gram of ice at 0.0 degrees Celsius. So the degree Celsius of this hot water will decrease because it is using its energy to heat up this cold ice. So first of all, it will melt this ice and then it will increase the temperature of the ice. They have said calculate the final temperature of the mixture of water and melted ice. One another thing is, as this hot water is poured into the ice, both of them will be in this container. So both of them will have the same temperature. So the final temperature of the mixture will be same. And the melted ice, they have asked the final temperature of the melted ice as well. So now let's go and figure the formulas. Okay, now let's go and figure out the formulas. So here the formula will be energy transfer from heat water, means the hot water's temperature has increased, so it has used some of the energies to melt the ice and then increasing the temperature of the ice or heat the ice water. So we can write the formula as mc del theta is equals to, first of all it has used this energy to melt the ice, so formula of melt is m of the ice into latent heat of fusion, which is mlf, plus the energy was also used to heat the energies, heat the ice water, so mc del theta. So here we can, let's do the math. We know the mass of the hot water as 325, which is in gram, which need to convert it into kilograms, so 0.325 into c, which is the specific heat capacity, which is we know 4190, which has been given in the previous part of the question. Okay, they will give you the specific heat capacity as 4190, and as I'm doing one part of this question, I'm not doing the whole, that's why I'm writing it like this, into the theta value. How it will it decrease? It was 85 degrees Celsius and this temperature will decrease, so 85 minus theta. And you might ask me a question right now, why I have written theta value after the 85? Because the theta value is small than the 85. The bigger value will always be in the first part, because the temperature cannot be like this, the temperature will be like this always, that the bigger value will be in the first part and then the smaller value will come into mass of ice. We know the mass of ice is 62.5, which is 0.0625 into latent heat of fusion, they have given is at 3.33 into 10 to the power 5. So this is our energy used to melt the ice plus the energy used to heat the ice water. The melted ice will be converted into the water, then this water will be heated, so we'll write the mc del theta. Now we will also use the mass of the ice, which is 0.065 into c, which is 4190, which we have written right here as well, which will be given in your answer in your question, into the change in theta. The del theta is this 0 degrees Celsius will now convert into a bigger value, because this temperature will increase. Now this temperature will increase, so theta minus 0, because this theta value is bigger than the 0 value, because it will become positive because the temperature will increase. Now what we have to do is we have to find these two theta values. As we have made this formula, now we have to find these two theta values. If you do this math and figure out the theta value, the theta value will come as 58.8 degrees Celsius. I'm not doing the workings today, just before 1 hour before the exam you guys have to do the formula. The most important thing of making you understand is this formula, how this formula actually works. How this formula actually works is what we have to understand in terms of doing this type of questions. So we are done with the most important thermal physics question. I will also provide another thermal physics question solving to you guys, so that you guys can prepare in a much better way. Alright, so let's solve the question number 12 right now. Bronze is a mixture of tin and copper. Tin melts at a much lower temperature than copper. Okay, this is a very important information. The tin melts at a lower temperature than copper. 2.7 kg of solid tin at a temperature of 295 Kelvin is added to this mass of molten copper at a temperature of 1520 Kelvin. Okay, so basically that what is happening is the temperature of molten copper is much higher. Its temperature is much higher than the temperature of solid tin. So what will happen right here is when you mix something cooler with something much more hotter than it, its temperature increases, right? Let's say we are dissolving actually not dissolving, we are actually immersing. Let's say we are immersing ice cubes, we are immersing 2 ice cubes on a hot water. So these ice cubes temperature is much less than the hot water. So when these ice cubes will be immersed into this hot water, the temperature of these ice cubes will increase. Let's say the temperature of this ice cubes first of all will decrease. The temperature will increase, that which means the ice cubes will melt. When it has completely melted, and then the ice cube's temperature will start to increase. First of all it will melt and then its temperature will increase. First of all it will melt, and then the temperature increases. In the meantime, the temperature of this hot water will decrease a little bit because its energy has been used to melt the ice cubes and then increasing the temperature of the ice cubes. So this is how we will do the thing. The thing is, the temperature of the molten copper is really high, so its temperature will decrease, and the solid tin first of all will melt. The solid tin will first of all melt, and then after that melting, then its temperature will increase. So basically these are the two important parts that we'll have to keep an eye on. So let's start solving this question paper right now. So basically the tin melts. They have said the tin melts and mixes with the molten copper to form molten bronze. Okay, they have asked us to figure out the final temperature of the molten bronze. So basically what we can write down right here is that this is the energy of the, I'm making you guys understand again, the energy of the hot water will be transferred to melt the temperature, to melt the ice cubes, and then increasing the temperature of the water from the melting of this ice cube. So what we can write here is that energy from copper, we can write energy from copper is equals to this energy, let's say this energy for the ice, let's say this energy of the hot water or the energy from copper is equals to energy increased to energy to melt tin, energy to melt tin, plus this is the melting, plus the increase in the temperature of tin, energy to increase the temperature of tin. So let's figure out each and every point one by one. First of all, let's figure out the energy from copper. This is the energy. So here we know that this energy will decrease a little bit. Why this? Sorry, the temperature will decrease a little bit. Why the temperature will decrease? Because the molten copper will use its heat energy to melt the solid tin and then increase the temperature of the solid tin. So by this term, this temperature will decrease, and it will decrease to a theta value, the value we don't know. So we will do that. We will do the formula. This will be is equals to mc del theta. Energy from copper is equals to mc del theta, which is equals to, the mass has been given as 10.5 kg into the C, heat capacity of molten copper is this 572 joule kg per Kelvin, into the del theta. The del theta means this 152 will decrease to a value. So we will write 152 0 Kelvin minus the theta. Some guys have a question, why have written this theta value after that? Because this theta value will be lower than this value. That's why we always write the higher value in the beginning and then the lower value in the end. Okay, so we are done with mc del theta. This is the value that comes. If we equate them, we will get a value like this, 9.13 10 to the power 6. If we multiply these two values and then it with this value, which will come as this is the theta. This theta is very important. This is what we are actually going to find. So now we have figured out the energy from copper. Now what we can do is we can figure out energy transferred to tin, because this energy from copper has been transferred to the tin. So we can take these two values together. Okay, so let's take them down. Energy transferred to tin is equals to this energy which has been used to melt the tin will be used a latent heat of fusion. So we will take the mass 2.7 into LF. So 2.7 into 5.92 into 10 to the power 4 joule per kg, and here we have to write the kg as well. Plus, now as we have added the energy to melt the tin, now we will add the energy required to transfer the to increase the temperature of this tin, to increase the temperature, which will be denoted as mc del theta, which will be denoted by mc del theta. So the mass of the tin is 5.92 into 10 to the power 4 joule. Sorry, this is the specific latent heat. We are looking after the mass of the tin, which is 2.7. 2.7 into the C, specific heat capacity of tin, which is this, which is 214, into, we know it had a theta value, and then it will decrease. Sorry, its temperature will increase. So its previous value was 295, so its value will increase to, let's say, a theta value. It will increase to a value of theta, and we know this theta value is greater than this 295, so we will put this ahead of that value, which is theta minus 295. We always add the bigger value first. After writing them all, now what we have to do is we have to just multiply this part and then this part. These two part will be multiplied. If we multiply this part, what we will get is 2.7 into 5.92. This comes as actually we can do the whole thing together. After doing the whole thing together, what we will get is we will get 1.00 into 10 to the power 4 joule plus 578 joule per Kelvin theta. This is the value that we will get after adding these two values. After adding those two values, we will get that value. Alright, so previously we have figured out the energy transferred from copper. This was the energy transferred from copper. And we know the formula energy transferred from copper was used to melt the tin, and then with addition to that to increase the temperature of the tin. So we have multiplied this energy transfer to measure energy transfer to melt the tin plus energy transfer to increase the temperature of the tin. So these are the two values that we have got. So we know they are equal, right? So we can write this value equals these two values, and then we can figure out the value of theta, which was the main question of the main question. Okay, so now let's go and figure that out. We can write according to this formula that we have previously written in the black marker. Energy transfer from copper is this, so we can write 9.13 into 10 to the power 6 joule minus 6 into 10 to the power 3 joule per Kelvin. This theta is equals to 1 into 10 to the power 4, this value, plus 578 joule per minus Kelvin theta. Okay, for not being confused, we can remove this joule part, and we can only consider these theta values, because this joule part are making things confusing. So you can also write it down as 6 into 10 to the power 3 theta. These are equal values, these are together as well. Now we have to make theta the subject and figure out what the value of theta comes as. Actually the value of theta comes as 1386 Kelvin. So this is our answer, which can be written as 1390 Kelvin in the final answer. So basically in this question, while solving this question, I didn't show all the workings because you guys are now in A2, and I think I don't need to show workings anymore because you grew up quite well. So this is the thing that I have figured out this value without showing the workings, and I didn't also show workings here. Figure out the value of theta as 1390. So please figure it out by yourself, and if you can't, then please practice how to figure out values. Otherwise, if I have done this by myself, then you would have never done this by yourself, which is very important in physics unit 5. Students a lot of times know how to do the math, but they don't become successful in terms of doing the math because they mess up in the calculation part. That's why I didn't show the whole. All right, so let's understand this question. They have said this is a very repetitive question, so let's understand it and answer it. This is a 6-mark study question, which is really repetitive, and I believe that this will come in your exam as well. The pressure inside a football decreases as the temperature of the air inside falls. While solving this type of questions, what we will do is we will write PV is equals to NKT, this formula. They have said as the pressure decreases, the temperature decreases. This is what they have written, right? So we know temperature should always be linked with the kinetic energy because temperature and kinetic energies are directly proportional. So as the temperature has decreased, the kinetic energy has also decreased. We have to mention that thing. As the temperature of the air decreases, the average kinetic energy of the molecules decreases. And we know when the kinetic energy decreases, kinetic energy should always be linked with P square by 2m formula. So when the kinetic energy decreases, the average momentum of the molecule will also decrease. This is the part. That means the kinetic energy decreases, the average momentum of the molecule is decreasing. Now as we have moved toward the average momentum of the molecule, let's say this is one part of the container and this is another part of the container. One molecule is going in this direction and colliding with the container of the wall. Now, if the average momentum of the molecule has decreased, when it will collide, it will bounce back, right? But the bouncing of the but it will bounce back with a lower velocity. It will bounce back with a lower velocity. So we can say the change of momentum during a collision with the container wall decreases because at first it collided with a higher velocity, but then it is coming back with a lower velocity. So we can say the change of momentum of a molecule during a collision with the container wall decreases because the change of momentum is not that bigger like the earlier ones. Now as the change of momentum had decreased, the rate of collision rate will decrease. It will collide with the container wall less number of time in a given period of time. In a given period of time, let's say it used to collide 10 or 15 times with the containers of the wall. Now the rate of collision will decrease. It will collide 5 or 6 times with the container of the wall in a given period of time. So we can say the rate of collision of molecules with the container wall decreases. Now as the rate of collision has decreased, we can say the rate of change of momentum has also decreased. The change of momentum has decreased as well as the rate of change of momentum has also decreased. So we have to mention these 2 points. Why the rate of change of momentum has decreased? Because in a given period of time, it is colliding less number of times. So the change of momentum is not increasing that much. The change of momentum has, on the other hand, decreased. Now here comes the 6th point. The 6th point is as the rate of change of momentum has decreased. Okay. Now the pressure will also decrease because the force has decreased. We know pressure is equals to force per unit area. As the rate of change of momentum has decreased, now it will collide with the container wall with less amount of force. As the force has decreased, we can say the pressure has also decreased because the pressure exerted by the gas decreases since pressure is equals to force per unit area. As the force has increased, the pressure is also increased. And why did the force decrease? Because the rate of change of momentum is equals to 4. We know force is equals to mv minus mu divided by time taken. If this rate of change of momentum has decreased, then this force will also decrease, and if the force decreases, then the pressure also decreases. So we are done with the 6 points. Please kindly memorize it by understanding. If you don't understand, if 1 or 2 points, still memorize and write it down in your exam if the question come like this, because this is a very repetitive question. All right, so let's solve this question as well together. The reason behind picking this question is in this type of question you have to do ratios in order to figure out the answers. So this type of questions are really important where one is multiple times of the other ones. So let's read the question. They have said Betelgeuse is a red giant star with a luminosity. Okay, they have given us the luminosity of Betelgeuse, and they have given us the peak intensity of radiation from Betelgeuse occurs at a wavelength of this. Okay, they have given us the wavelength of the Betelgeuse. They have given that a website claims that the radius of Betelgeuse is 1000 times the radius of the sun. So these type of questions are very important because here they have written about the multiple times, that one is multiple times bigger than the other ones. They have also said assess the accuracy of this claim, and they have given us the surface temperature and they have given us the luminosity as well. They have given us the surface temperature and the luminosity of sun. Previously they have given us the luminosity of Betelgeuse. Now they have also given us the luminosity of sun. So let's solve this question together. Now they have asked to find the radius of Betelgeuse, whether it is 1000 times than the radius of the sun. So to find the radius, they have given us the luminosity of the Betelgeuse and the luminosity of the sun. So first of all, let's write the formula of luminosity. One of the formula of luminosity is 4 pi r squared sigma into temperature to the power of 4. Now we have got the luminosities. 4 pi is a constant. We have to find out the radius. Sigma is the constant. In order to figure out them all, we have all of them except the temperatures. We have to figure out the temperatures in order to be able to figure that out. We have the temperature of sun as well. We just need to figure out the temperature of Betelgeuse, and in order to find out the temperature of Betelgeuse, they have given us the wavelength of Betelgeuse. So let's use it to find out the temperature. We know lambda max T is equals to 2.898 into 10 to the power minus 3. Now the temperature will be 2.898 into 10 to the power minus 3 divided by the lambda max. They have given us the lambda max as 850 nanometer, and you need to convert it into meter. 850 into 10 to the power minus 9 meter. Now we will get our temperature, which is 3410. This is the temperature of Betelgeuse. Okay, we have got the temperature of Betelgeuse, and we have the temperature of sun as well. Now as we know that the radius of Betelgeuse is 1000 times the radius of the sun, so we will take which one is bigger. The radius of Betelgeuse is bigger. We will take the radius of Betelgeuse, or the luminosity of Betelgeuse, in the numerator. So what we'll do is we will write it like this. The bigger one will be in the numerator, the luminosity of B divided by the luminosity of sun, as the luminosity of B is bigger. So we'll write the formulas: 4 pi r B squared temperature B to the power of 4, and the sigma will be right there as well. 4 pi r squared sigma, this is the sun and this is for the temperature of the sun, into 4. This is how we will write it down. Now out of this we have all of them, right? We have all the values. We have the red, we have the luminosities, we have the 4 pi, we have the radius. We have to figure out the radius, we have the sigma, and we have the temperature. So we have to make radius the subject, because we are talking about the radius. The one's radius is bigger than the other ones. So if we make radius the subject right here, radius of B divided by radius of sun squared, both of them will be sun squared. Now what we can do is, this is LB into these ones, all of these ones will go right here. So 4 pi r squared into sigma into temperature to the power of sun to the power of sun, this is the temperature of the sun, divided by all of these values will come right here. So luminosity of sun into 4 pi r, sorry 4, no, the r will not come right here, sorry, my bad. Here the r will not come, the r will not come because the r is right here. Only the 4 pi part will come. Only the 4 pi part will come. 4 pi into sigma into temperature to the power of 4 of the Betelgeuse, because the Betelgeuse has come here, right here. Okay, so we have derived our formula. Okay, now we can take away this radius by root overing them overall. So we can take out this radius by root overing them all. So we can take away this radius, we can take away this radius and root over them. So root overing them overall will take out the radius. So now our formula is RB divided by RS is equals to root over luminosity of B into 4 pi into sigma into temperature to the power of 4 of the sun, divided by luminosity of B into 4 pi into sigma into temperature of Betelgeuse to the power of 4. Now if we put everything right here, we will get the answer. So let's put it right here. It will be like this. Now what we can do is we can remove all the constants. This 4 pi sigma is a constant, this 4 pi sigma is constant. So the formula will be radius of B divided by radius of sun is equals to root over luminosity of B divided by luminosity of S into temperature of S to the power of 4 divided by temperature of B to the power of 4. Here it was in divided form, right? We have just made it, both of them were in divided form. So if we take out the multiplication, we have to move the denominator to the numerator and the numerator to the denominator. That's why we have made those changes. Sorry, my bad, it was multiple before as well, so we didn't need to take the changes. We have just removed all the 4 pi 6 because they were constant for both of them. We have just lb into ts4 lb into tb4, we have written like this. Now if we put all the formulas right now, it will be, let's write the formulas right here. Let's write the formulas right here. That it will be root over 4.49 into 10 to the power 31 divided by 3.83 into 10 to the power 26 multiplied by 5800 to the power of 4 divided by 3410 to the power of 4. So the value comes as 991. So RB divided by RS is equals to 991. So we can say it is not 1000 times, it is less than 1000 times. So we can say the claim is incorrect. The claim is inaccurate. So this is how we will do this type of ratio maths, which are really important in physics unit 5. I have shown one, but it might come in your exam in a different way. So make sure you're understanding it by heart and practicing it before your exam, just 1 or 2 hours before your exam. Fine. They have given us the force time graph. So come on, let's read this question right now. What they have written. They have written the graph shows how the force varies with time for an object performing simple harmonic motion. They have given us the force time graph. They have given us 4 examples and asked us to figure out the displacement of the varies with time. Okay, so is it a force time graph? We can also refer it as an acceleration time graph as well, because we know force is equals to mass into acceleration, and force and acceleration is directly proportional. So both of their graph will be more or less similar. And another thing that I want to make you guys understand is F is equals to minus kx. Okay, the graph of force versus time is out of phase with displacement by pi radians. Okay, we don't need to know about the pi radians at the moment. What we can actually do is this is a sine graph, right? This is a sine graph. If this is a sine graph, if force is a sine graph, then the displacement will be a negative sine graph. Will be a negative sine graph. Will be a negative sine graph, but exactly the same. It will start. It is starting from here and going like this. It will be like this. The graph will be like this. So basically D is our correct answer. According to F is equals to minus kx, the displacement is negative of the force. So we can say this graph will be a negative sine graph. So our correct answer will be D. Now moving forward, they have asked about the velocity. They have asked us about the velocity. So we know velocity is the derivative of displacement. Or we can also say one thing. Let's erase that part and write it down like this. When something is in simple harmonic motion, when the displacement is maximum, at that time velocity is 0. And when the velocity is maximum, okay, at that time the displacement is 0. When the displacement is maximum, the velocity is 0. When the velocity is maximum, the displacement is 0. So here, when let's say take this graph. This is a VT graph, right? Sorry, this is the displacement time graph. So if the displacement is negative, if the displacement is 0, the velocity will be at max. Okay, the velocity will be at max. And when the displacement will be 0, sorry, when the displacement will be maximum, like this, here, I say actually, when the displacement is at maximum, the velocity will be 0. So basically, graph B corresponds this thing. Right here, let's say right here, when the displacement 0, the velocity is at maximum. This is our VT graph. When the displacement is 0, the velocity is at maximum. So basically, graph B corresponds to that thing. So we can say 10 is our answer for displacement and time graph. If we have given the displacement graph and we have asked to find the velocity time graph, you have to look one thing, that is when in the displacement time graph the displacement is 0, at that time the velocity is at maximum. When the displacement is at maximum, the velocity is at 0. So B is our velocity time graph. A similar question has arrived in the October 2024 paper as well, where I have solved this question in a very detailed way. Still, I will solve it right now so that you guys can go through it just before your exam, or just 2 or 3 hours, or just 6 or 7 hours before your exam, and revise them, because this is a very important question and it might be in your exam day as well. So please go through the October 24 paper as well. There is a more detailed explanation, and there is also some more questions as well regarding this. So basically what they have said right here is a particle is undergoing simple harmonic motion. Okay, very good. They have given us the VT graph. They have given us the VT graph of the simple harmonic motion. In the VT graph they have given, and they have asked to write the displacement time graph. We know speed is equals to distance divided by time taken. Okay, speed is equals to distance divided by time taken, and distance is equals to speed into time. In simple harmonic motion, specifically for simple harmonic motion, when the speed is 0, at that time the displacement is maximum, and when the displacement is 0, the speed is maximum. This is one thing that you guys need to memorize or remember for simple harmonic motion. When the speed is 0, the displacement is maximum. When the displacement is 0, the speed is maximum. Here, when the speed is 0, at that time the displacement must be maximum. For that reason, this is not maximum. Our A cannot be answered. Our C cannot be answered because the displacement is also 0. This displacement cannot be 0. Displacement needs to be maximum when the speed is 0. Here, when the speed is 0, the displacement is maximum. That's why this is our correct answer. Here, when the speed is as maximum, the displacement is minimum. That's why this is our correct answer. The correct answer is B. We are done with this paper as well. The simple harmonic motion of displacement time graph. And another thing is, when it is positive, it will be a negative graph. When it is negative, it will be a positive graph. And in the D part, the displacement and the speed, both of them are positive. So that's why, just because when the speed is 0, the displacement is maximum, but it is in the positive line. It cannot be in the positive x-axis. It needs to be in the negative x-axis. That's why B is the correct answer and D is not the correct answer. A pan of water is heated on a hot plate as shown. A mass of 0.65 kg of water is boiled away in a time of 1250 seconds. The power of the hot plate is 1800 watt. Calculate the efficiency of the boiling process. They have given us the specific latent heat of vaporization of water 2.26 into 10 to the power 6 joule per kilogram. So basically they have asked us to calculate the efficiency, and we know the formula of efficiency is useful power output divided by total power input, right? This is a very important formula, that efficiency is equals to useful power output divided by total power input. Now here the total power input is the power of the hot plate, right? This is the power of the hot plate, and this is the power that this hot plate will be providing to the pan. And now it depends upon the pan how much it can take and how much output it can give us, and on that output our efficiency will depend. So let's write 1800 right here at the denominator, because this is the total power input. Now useful power output is needs to be figured out by the formula of power. So we know power is equals to work done divided by time taken. So here power is equals to, my work done will be the mass of water that is boiled and the latent heat of vaporization. So it will be 0.65 into this value divided by the time taken, because work done divided by time taken, right? So we can write it down as 0.65 into 2.26 into 10 to the power 6 divided by 1250. So our power output value will be 1175 watt. So this is 1175 watt. right? This will give us a value of, we can actually multiply it with 100. It actually depends, it's your decision whether you want to multiply with 100 or not. I will always multiply. So this will give us a value of 65%. Now moving on, the next part, it says putting a lid on a boiling pan reduces the energy transfer needed from the hot plate to keep the water boiling. So basically when you put a lid on the boiling pan, the only thing that comes to my mind is, let's say I am putting a lid right here on the boiling pan. So what it will happen is, if there wasn't any boiling pan, then the liquid that was vaporized, I mean the liquid that was vaporizing would have escaped, right? The liquids, they would have escaped. The gas would have been escaped. The vaporized liquid, or yes, the vaporized liquid would have escaped. That they have turned into gas and they would have basically escaped. But if there is a lid right here, they won't be able to escape. And this is the answer that we will have to write. Let me bring the answer. So basically this is going to be our answer, that when you put a lid, less steam actually escapes, and so less energy is transferred to the surrounding, because less amount of vaporized gas is going to the surrounding. Now the reason behind putting another 2 points is, actually giving these 2 points will award you the full mark, the full 2 marks. But still I have added few more points, the third and the fourth point, to make you guys understand few more points, because understanding these 2 more points will allow you to grasp few more ideas which might be in need in the later sessions of the exam. So it says steam condenses at the lid. So why does the steam condenses at the lid? Because basically the temperature of the lid is definitely less than the temperature of the steam, right? Because steam has converted into steam from liquid water, and that liquid water was in direct contact with the hot plate, or the hot plate was exerting power on the liquid water. So this steam basically has temperature higher than the lid. So when the steam and the lid is in contact, the steam condenses. It condenses means it returns back into liquid, and when it returns back into liquid, it releases the latent heat of vaporization that it has used to turn from liquid into steam. So it has basically previously used latent heat of vaporization, or the latent heat of vaporization energy, to convert from liquid to steam. Now when it has condensed at the lid, now it is returning that latent heat of vaporization energy to the pan. So at that time it actually releases the energy, and when it releases the energy to the pan, so this energy is going back to the hot water. So when it is going back to the hot water, so the latent heat of vaporization used is less. So when lesser amount of latent heat of vaporization energy is used, we can say the hot plate requires less energy transfer. He actually needs to transfer less amount of energy to keep the water boiling, because less amount of energy has been actually escaping to the surrounding, and a bigger amount of energy is returning. So when the energy is returning, less energy is escaping. So the hot plate needs to do, or needs to transfer less energy to keep the water boiling. Now I will be adding one extra explanation right here to make you guys familiar with this thing. The explanation is right here. It says steam takes energy from the water to evaporate, right? And when steam condenses on the lid, it releases that energy. This energy goes back into the pan, warming it and reducing heat loss. This question says a student hangs a mass of 0.22 kg from two identical springs as shown. She displaces the mass vertically and the mass oscillates with simple harmonic motion. The student measures the time for the mass to complete 30 oscillations. Although she was measuring how much time it takes for 30 complete oscillations. She repeats this measurement. Her measurements are given below. So basically she has given the time for two measurements. Okay, now it says the springs are taken from a box labeled k is equals to 21. So they have given us the stiffness constant value. Deduce whether the value of k stated on the label is correct. So it is asking whether this k is correct. So to figure out whether the k is correct, we'll have to figure out the k value. Do we know the mass? Yes, we know the mass. We know two t values and we have to figure out the k. So we know there is a formula which is time period is equals to 2 pi into root over mass by k, right? We know the mass, we'll have to figure out this k, and the time period is a confusion for the students because we have two time period values. So what we'll have to do is something in which students face the issue. So the thing that you guys will be doing is, as they have given us two time period values, several multiple measurements are always done to calculate the mean, and when you calculate the mean, the uncertainty decreases. Okay, so that's why we actually do calculate the mean, the random error decreases. So we'll actually figure out the mean value right here. So to figure out t mean is equals to 13.65 plus 13.70 divided by 2. So this will give us a value of this is the time that we are figuring out. Actually, this is the time taken. Okay, time taken. So it comes as, so basically this comes as 13.675. So this is basically our mean time taken. Now we are not going to work with the, this is the time taken. Okay, this is the time taken, but here this formula is for time period. This is for the time period, and time period means the number of oscillations, actually the oscillation, the time taken for one particular oscillation. So basically the time period means the time taken for one complete oscillation. Now this time was for to complete 30 oscillations. Okay, the time for the mesh to complete 30 oscillations, but time period is for one complete oscillation, the time it takes for one complete oscillation. So we will divide this by 30 to get the time, as this is the time taken for 30 complete oscillations, and we need the time for one complete oscillation, that way we will divide it by 30. So 13.675 divided by 30 will give us a value of 0.456, and this is the value we will use right here. 0.456 is equals to 2 pi root over mass by k, and if we make 0.456 is equals to 2 pi into root over 0.22 by k, and if we make k the subject, our k will be equals to 20.9 Newton meter minus 1. So make sure you are being able to do this one. I'm not gonna do the rough work right here because in the last question I have done the rough work. So in this question I'm not gonna do the rough work. You should be able to do it. The k value is 20.9 Newton meter 1 per meter, Newton per meter. So basically the main thing right here was to calculate the mean time taken, and we know the time taken is for 30 complete oscillations, and the time period means the time for one complete oscillation. So that's why we have divided the time taken for 30 complete oscillation by 30 to get the time taken for one complete oscillation. This was the main thing about this question, and we have taken the mean value right here rather than taking, we are actually confused, right, whether we should take this time or this time. That's why we have taken the mean value. All right, so now let's go through this. It says the student attaches the mass to one spring, all right, and holds the other end just like the way he's holding it right here. She sets the mass into oscillation by oscillating her hand vertically as shown. The student increases the frequency at which she oscillates her hand. She keeps the amplitude of oscillation of her hand constant. Alright. She observes that the amplitude of oscillation of the mass increases to a maximum and then decreases. So it is saying that the amplitude of oscillation increases to its maximum. So this should include, this should After reading this maximum word, one line should come to your mind: the resonance. The very common question that comes in every exam sessions, something that I've discussed previously as well, right? The resonance is occurring. That's why the amplitude of oscillation has reached its maximum value. The amplitude of oscillation reaches its maximum value when resonance occurs. So basically, when resonance occurs, the resonance occurs when the driving frequency, the frequency with which he is, she is oscillating the spring mass system using her hands, the driving frequency is equal to the natural frequency of this spring mass system. When this driving frequency, which is she doing with her hands, matches the frequency, the natural frequency of the spring mass system, resonance occurs. And when resonance occurs, there is a maximum transfer of energy to the spring mass system, and the amplitude increases to its maximum value, right? Something that we have learned previously. So basically, this is going to be your answer, that when the driving frequency is equal to the natural frequency of the spring mass system, resonance occurs. There is a maximum transfer of energy to the mass spring, sorry, here it will be mass spring system rather than spring, it will be mass spring system, and the amplitude increases. The next question says the student makes the following conclusion. What is the conclusion? As the frequency is increased, the amplitude of the mass increases to a maximum. Yes, we know this. So energy conservation does not apply to this situation. No, this is actually wrong. The question says explain whether conclusion is correct. No, it is incorrect. Why it is incorrect? We know one thing. We know one thing. Let's understand this completely right here. We know one thing. That is, when he is moving his hands to oscillate the spring, the energy is transferred from his hands to the spring, right? And some of the energy is also transferred to the surrounding, right? Some of the energies are transferred to the surrounding, and some of the energies are transferred to the spring mass system. Now she has said that when the amplitude of the mass increases to a maximum, so the energy does not apply to this situation. So energy conservation doesn't apply to this situation, it says. So basically, when amplitude is maximum, at that time we know there is a maximum transfer of energy. There is a maximum transfer of energy to what? There is a maximum transfer of energy to the spring mass system, and when there is a maximum transfer of energy to the spring mass system, energy that is going to the surrounding will be minimum. Okay, let's say the hand is giving 50 joules of energy, the hand is exerting 50 joules of energy on the spring mass system. So as amplitude is very high, so basically the spring mass system will get 48 joules of energy, and the surrounding will only get 2 joules of energy. So when the spring mass system is getting the maximum amount of energy, the surrounding is getting minimum amount of energy. Why? Because it says amplitude is maximum. When the amplitude is maximum, there is a maximum transfer of energy, and we know it is carried out in a closed system. And in a closed system, the total energy must always be conserved. The total energy must always be conserved. The energy that he will put into this system will be divided between the spring mass system and the surrounding. So this energy will always be conserved. This 42 plus 2 will always be equal to 50 joule. So that's why we can say the energy will be conserved. So the statement was wrong. So we can write it down like this right here. So the energy from the student's hand is transferred to the oscillating mass, and some of the energy is transferred to the surrounding. When the amplitude is maximum, minimum energy is transferred to the surrounding. In a closed system, total energy is constant. So the student is incorrect. Okay, the student is incorrect. Now we are done with this spring mass system question. This was one of the most difficult one in the recent years. Now let's move forward to solving few more difficult questions in. Alright guys, now let's have a look at this question. It says the Hertzsprung-Russell diagram for a star cluster is shown. So basically this is a star cluster question. The luminosity has been given, and they have given us the temperature in Kelvin in the in the x-axis. The question A says add a scale to the horizontal axis. Now this is a very important question. These type of questions are very common in recent years. We know the horizontal axis is the temperature axis, which is a logarithmic scale, which should be given in our logarithmic scale, because the values are so big that it cannot be accommodated in a linear scale. That's why it is given in a logarithmic scale, and the scale will be reverse scale. It will start from here and go like this. It will be a reverse scale, unlike the x-axis usually which we do in this position, right? It will be a logarithmic scale and a reverse scale. Okay, now let's have a look at one of this HR diagrams. So basically in this HR diagram, you can see it is in a if I make it bigger, it is like this. The logarithmic scale is like this. It is reverse, and it is logarithmic from 2500, 5000, 10,000, and we know the sun is right here. The sun is somewhere right here, which is at 6000 temperature in Kelvin, which is at 6000 Kelvin. Okay, now let's draw our one like this right here. Let's draw our one like this right here. Okay, now we know this position is going to be 2500, and this position is going to be 5000. This one is going to be 10,000. This one 20,000, and this one is 40,000. And we know our sun will be somewhere right here, or basically it will be, yeah, not like here, it will be a little apart like this, which is somewhere right here, which is going to be 6000. Basically it will be a little like this, which will be 6000. Okay, this is for the sun. This is for the sun. This is how you will have to draw this one. Hopefully you guys have understood this part. Now let's move on to the part B. Actually we'll have to draw it like this. Yeah, perfect. Now let's move on to the 20B. It says explain how this Hertzsprung-Russell diagram. Basically you don't need to mention this sun like this the way I have given, but I have drawn this part to make you guys understand the thing, nothing else. You can just erase them because this is not important. Only drawing the logarithmic scale was important. You can remove these parts. Okay, this is not important. You'll just need to draw this logarithmic scale in a reverse scale and in a logarithmic scale, nothing else. The horizontal axis. Explain how this Hertzsprung-Russell diagram shows that the star cluster is not a young star cluster. You should refer to groups of stars and their positions on the diagram. Now we know, if you look at the HR diagrams, we can see that these are red giants, right? These are red giants, and these are white dwarfs, right? These are white dwarfs. So basically red giants and white dwarfs are present in this star cluster. So a star cluster, if a star cluster is a young one, in a young star cluster there is only this main sequence part. In a star cluster there is also only this main sequence part. There is no red giant or a white dwarf, because we know red giant and white dwarfs are the later stages of the star's evolution, right? So as there is red giant and white dwarf, we can say it is not a young star cluster. The explanation will be like this. The diagram shows red giants at the top right. It also shows white dwarf at the bottom left. Okay, white dwarf and red giant. Both red giants and white dwarfs are stars in the later stages of their life. A young star cluster would only have stars on the main sequence. Okay, the diagonal line, I mean this one. Because the star cluster has red giants and white dwarfs, it is not young. Alright, so now this question says the graph shows the variation of binding energy per nucleon with proton number Z. This is the binding energy per nucleon on the y-axis, and this is the Z. Alright, it says in one possible fusion reaction, a nucleus of 2H fuses with a nucleus of 3H. So basically two hydrogens are fusing, one is 2H and one is 3H. A nucleus of 4He and a free neutron are produced as shown in the following nuclear equation. So 4He is formed with a neutron. Determine the energy in megaelectron volt released when a nucleus of 2H fuses with a 3H. So basically the energy that will be released right here. So basically in this type of reactions, they give us the binding energy per nucleon. If we have got the binding energy per nucleon of all these three materials, we can subtract these reactants from the product to get the energy in megaelectron volt released. Okay, so now they have given us a graph from where we will have to figure out the binding energy per nucleon. So for 2H, we will have to locate where the 2H is. We can see that 2H is right here. 2H is right here, which is in the middle like this. The 2H is right here, and we know if this is 1 and this is 2 and there are 5 boxes right here, each box will correspond to values. So if this is in the middle, it will be 1.1. mega electron volt. Okay, mega electron volt. Don't forget the mega electron volt. Now the next part is 3H. So basically my 3H is right here, which is absolutely 2.8, right? Just one box, just one box before the 3, so it is 2.8. And the next part is 4He, which is formed right here, so which is exactly 7 mega electron volt. So we have got all the three binding energy per nucleons of these three particles, and this neutron will not have any binding energy per nucleon because the neutron is not an element. So basically they have asked us to figure the energy in mega electron volt release. Now these type of questions are very common, but I have chosen this question because it was a little bit different from the other ones. So basically we have figured out the binding energy per nucleon of 2H was 1.1, which another one 2.8, and the other one is 7. So we'll subtract the reactants value from the product. So 4, we'll have to take this 4 into consideration as well. Don't ever forget to take this into consideration because there was 4 helium molecules. So 4 into 7 mega electron volt. Basically we'll have to take that into consideration, minus 2 into 1.1 mega electron volt plus this 3 into 2.8 mega electron volt, which will give us a value of 17.4 mega electron volt. This is the energy that was released, and they have asked us our answer to be in mega electron volt. So that's how we have done this question, and these type of questions are very common in recent years, so make sure you're understanding this. In most of the questions, this mega electron volts, I mean the binding energy per nucleon, will be given. You will just have to figure out this by using this. Okay, but the thing is, this question was a bit different, that's why I have used this one to make you guys understand this one. If they didn't give the binding energy per nucleon, you can figure it out from the graph. Now let's move on to another tricky question as well as the common one. Alright, so now let's understand this question. It says the escape velocity is the minimum speed needed for an object to escape from the gravitational field of a planet. So basically, let's say this is the Earth, and Earth will have its gravitational field up to this position. Okay, let's say the gravitational field of the Earth will be up to this position. Though I'm drawing it, I'm just making it to make you guys understand, nothing else. Okay, now let's say its gravitational field will be up to this position. Now for an object to escape this part, okay, for an object to escape this part, it will just require for that object to move away from this gravitational field, it needs to have a escape velocity, and that escape velocity is the minimum velocity which this particular object will have to move away from this gravitational field of the Earth and go right here. So as it has escaped from the gravitational field of the planet, no more gravitational force of the Earth will be exerted on it. So this is how it actually meant, nothing else. This is what they actually meant. Now it says the escape velocity is the minimum speed needed for an object to escape from the gravitational field of a planet. So if an object have this minimum speed, which is known as the escape velocity, he will be able to move away from the gravitational field of a planet. An object traveling at the escape velocity has a kinetic energy equal to the magnitude of the gravitational potential energy at the surface of the planet. So basically this escape velocity will have a kinetic energy value which will be equal to the gravitational potential energy at the surface of the planet. And this is one question, the gravitational potential energy, something that we have learned previously as well, right? We know that gravitational potential is equals to gravitational potential energy gravitational potential energy per unit mass. So gravitational potential energy will be gravitational potential into mass. So it will become minus gm by r into m. So this is minus gm m by r. This is the formula of the gravitational potential energy, right? Which will be equal to the kinetic energy. And we know the formula of kinetic energy is half mv squared. So they have asked us to derive these two formulas into this position. So now let's derive this one like this. So it will be like this. Okay, we know the gravitational potential energy, as they have said, the gravitational potential energy was equal to the kinetic energy. We have written for the formulas and we have put this equal because they have said equal. Now if we make v square the subject, then this both the m, the small m, gets cancelled out, and we can put it like this: v square is equals to 2gm by r. Okay, and we can write v is equals to root over 2gm by r. This is how you guys will have to be able to derive this map. Hopefully you guys have understood it. Now moving on to the BI, it says, show that the escape velocity for a mass at the Earth's surface is about this. They have given us the mass of the Earth and they have given us the radius of the Earth. Nothing else. We will just have to put these two values right here in this equation to calculate this escape velocity. Now this is how we will be able to this math. 2 into gm, 2 into gm, so we know this g is a constant 6.67 10 to the power minus 11, and this mass is the mass of the earth, which is 5.9 10 to the power 24, and this radius is given right here. This is how we have calculated the escape velocity that they have asked us to calculate, and easy peasy, lemon squeezy, 2 marks. Now moving on, in this question it says, when the earth formed, a large proportion of the gas in the earth's atmosphere was hydrogen. All right, explain why hydrogen gas is no longer a large proportion of the gas in the Earth's atmosphere. Now, after reading just after reading this line, one thing that should come into your mind: why this hydrogen gas is no longer in the large proportion in the Earth's atmosphere? Maybe that hydrogen gas had an escape velocity. We are talking about the escape velocity in the first part, right? You should always relate this question with the previous part. Always relate, let's say, this two part with this part. You should always relate your questions to the earlier parts of that particular question. Now it was talking about the escape velocity. If someone has a certain velocity, at a certain velocity it will be able to escape the gravitational field of a planet. So as hydrogen gas was previously present but now it is no more, so that means it has escaped, right? It has escaped. Now it is saying that no further calculation is necessary. You don't need to show further calculation. Here they have said the velocity of hydrogen was 1900 meter per second at 20 degrees Celsius. Now, if the temperature changes, this velocity will also change, right? Because the kinetic energy changes. So basically, if the velocity becomes more, let's say if the velocity has become 2000, okay, this velocity maybe was the escape velocity, or maybe the velocity was like this. Let's say this velocity, no, this wasn't actually the escape velocity, this was normally the velocity at 20 degrees Celsius. Now if it becomes 20,000, or even if it increases to a very large value, then it maybe will have that escape velocity, and as it will have a escape velocity, it will be able to escape from the gravitational field of the earth. That's why it is no longer present in large proportion in the earth's atmosphere, right? So this is what we can actually mention, that there is a larger range of molecular speed. All the hydrogen in the earth will not have this 1900 value, right? Some of them will have 20,000, some of them will have 50,000, some of them will also have 1000, right? So molecule will be traveling much faster than 1900 meter per second. So there will be some molecules with a greater speed than the escape velocity. There will be some molecules, and they will have enough kinetic energy to escape the gravitational field of the planet. So basically this question should be related with the previous part of the question. That's how you should move forward to solving the questions. Alright guys, so now let's solve this question. It says, in the 18th century, Cavendish carried out the first experiment to determine the gravitational constant G. We know there is a gravitational constant G, right? The experiment used two lead spheres. Alright, a physicist planned to investigate the gravitational force using the lead spheres identical to the ones used in the Cavendish's original experiment. One of the spheres had a diameter and a mass of this, and the other second sphere had a diameter of this and the mass of this. All right, the minimum force that could be measured by the physicist was this. This is the minimum force that they can measure between these two spheres. Deduce whether the physicist would be able to measure the gravitational force between the two spheres. So basically this is the minimum force that the physicist can measure. So if this is the minimum force, then we can figure out with this minimum force how much can be the separation between these two spheres, and then we can figure out that radius between these two spheres, or the separation between these spheres, using the formula F is equals to G m1 m2 by r squared. We have got the force, we have got the two masses as well as this radius. So we have got these two masses, this mass and this mass, and we will just figure out this radius, and we will figure out how much radius or how much separation it can have with this minimum 50 Newton of force. So let's write it down, 50 micronewton. We need to convert micronewton, this micronewton. So we know this will become 50 into 10 to the power minus 5 sorry, 10 to the power minus 6, my bad, 15 to 10 to the power minus 6, which is equals to g is 6.67 into 10 to the power minus 11 into the two masses. One is 158 into 0.73, right? I'll convert both of them and divided by the radius. So we'll just have to make this radius the subject. So this radius will go right here and this value will come right here and we will divide it. So we'll figure out the radius value as r is equals to 0.012 meter. So basically this is going to be this can be the maximum separation between the two spheres to be able to get this minimum force. Okay, this is the minimum force that can be measured. So for this minimum force, this can be the maximum separation. For this minimum force, this is the minimum force, and for this minimum force, that can be the maximum separation between the two spheres. Now let's see whether this separation between the two spheres are actually within this maximum separation range or it is greater. If it is greater, then they won't be able to measure, and if it is within the range, then they will be able to measure. Now let's think it of the one sphere is like this and the second sphere is like this. The second sphere will be like this. Okay, not so basically let's think it of as the second sphere. Okay, so basically there are the two spheres. Now the two spheres will have radius, right? The two spheres will have radius. We know this is, they have given us the diameter, so we'll have to divide it by 2. We'll have to divide them by 2 and we will have to add both of them to get the the maximum separation between these two spheres. So radius will be equal to diameter divided by 2 plus the diameter divided by 2 of both these ones, this value as well as this value. This is the maximum separation between their centers, right? So it will become 30.5 into 10 to the power minus 2 into 10 to the power minus 4, minus 2 divided by 2 plus another one is 2.5. So 2.5 into 10 to the power minus 2 divided by 2. So this will give us the maximum separation that is happening, which is 0.165. Now this is basically the maximum separation between the two spheres, but the maximum separation that can be is 0.012 if the minimum force is this much. So for this minimum force, the maximum separation can be 0.012, but actually the maximum separation is 0.165. So we can say the physicist wouldn't be able to measure the gravitational force. We can say as 0.165 is greater than 0.012. Okay, he cannot measure the gravitational force between the spheres. So that's how our answer is going to be. Now moving on to the next question. It says experiments to determine G have been usually been carried out with large masses. In 2021, physicists at the University of Vienna carried out an experiment to determine G using Goldschmidt with masses of less than 100 milligram. All right, they obtained a value of G equal to this. They have given this 1 meter cube per kilogram per second squared, so that this is a correct unit for G. Now to figure out the correct unit of G, we will have to bring the formula which includes G. F is equals to GMM, this is smaller m, sorry, GMM by r squared. So we'll have to make this G the subject. So it will become G is equals to F into r squared divided by the two masses. So as they have asked us to show these units, we'll have to convert it into its units. So the unit of force is Newton multiplied by the r squared. Radius is measured in meter, so it will become meter squared divided by the two masses. We know masses are measured in kilogram. So as there is two m, we can say m squared, which is kilogram squared. Now this Newton needs to be into its base units, right? So it will become, we know Newton means force, and we know force is equals to mass into acceleration, and mass is kilogram and acceleration is meter per second squared, right? So we'll write kilogram meter per second squared multiplied by meter squared divided by kilogram squared. Okay, so um, this kilogram and one of this kilogram will get cancelled out, so there will be only 1 kilogram left. All right, and this m and this m will get cancelled out, so there will be only 1 m left. So the things left are is s minus 2 into m divided by the kilogram. If we bring all of them upward, it will become s minus 2 into, sorry, my bad, there was a mistake, my bad. Sorry for that mistake. Basically, as both of these masses are in the same, they're both are in the numerator, so they will be multiplied, so it will become meter cube into this s minus 2, and when this kilogram will go up, it will become kilogram minus 1. So that's how it is like this. Hopefully you guys have understood this one. This was an AS physics question, nothing else. So we have showed that it is exactly the same as this one. Now moving on to the next part, it says the physicist concluded that their value of g was within reasonable agreement with the standard value of g. Explain the validity of their conclusion. They have given us the standard value of g. Now this type of questions we'll have to always look after the previous part of this question. Always look after the previous part of this question. Now they obtained a value of this value. They obtained this value. This value will be a reference value. This one is a reference value which they obtained, and this one is actually the value, that is the value of g. This is the actual value. Now the question says explain the validity of the conclusion. To explain the validity or to evaluate the validity, we'll have to use the formula of percentage difference, something that we have used or learned in our AS physics. So we know the percentage difference formula is actual value minus the reference value divided by the actual value into 100%. Okay, so this is how we'll be doing the math. The math will be done like this, that just give me a minute. Percentage difference is equals to, which one is the actual value? Our actual value is this 6167 to 10 to the power minus 11, right? Something that we have learned, and it is in the back end of our page. Multiply minus by the reference value. The reference value is this one, which they have figured out, which is 6.05 to 10 to the power minus 11, divided by the actual value, which is 6167 into 10 to the power minus 11 multiplied by the 100, as the formula suggests. It will give us a value of 9.4%. This is how we will evaluate this. Okay, this is how we will evaluate this. We can also say, as the percentage difference is very low, less than 10%, we can say yes, it can be concluded as a standard value of g. FAQs that might come in your exam, that I am predicting that it will definitely come. One of them is trigonometric parallax, which is a 4 marks question. If you don't know how to answer it, or you don't understand it, you don't have time left for them to understand right now. It's better to memorize it, because this is the same question that every time comes. If they ask you to how to calculate the distance to nearby stars, how astronomers use parallax method or Ovel's trigonometric parallax to calculate the distance to nearby stars. When they mention distance to nearby stars, then please write the first 4 points that I have written for you guys. And they ask how astronomers determine the distance to distant stars, not the nearby stars. The nearby stars for the first one, if they ask about the distant stars, then write the second answer that I have written, which is also a 4 marks question. And another very repetitive question of 2 marks, which is the definition of or condition of simple harmonic motion. So these are the 3 questions which you should memorize before going to the exam, because it might come. And now let's go through some of the more repetitive questions which may come. These are the frequently asked questions that comes in physics unit 5. So please memorize all of them and take a screenshot. This is another very important question, the stellar evolution, the evolution of the sun, the evolutionary phases of the sun with reference to the HR diagram. This is a 6 marks question which maybe will be in your exam today. So please memorize it as well before going to the exam. Now in this question it says a 150 gram mass was hung from a spring as shown. the spring extended by 7.5 centimeter. So it's extended by 7.5 centimeter means it is the change, right? So it is del x. This is going to be my del x, right? Now the next part says the mass was displaced vertically 3 centimeter from its equilibrium position. So it was displaced 3 centimeter from its equilibrium position. All right, and then the mass oscillated vertically. So it was oscillating vertically. This is important information. It says explain why the motion of the mass was simple harmonic motion. This is a very easy 2 marks question that is more or less present in every exam paper. And the answer of this question is very easy. The answer is that when you displace something from its equilibrium position, let's say if this is the equilibrium position and you have displaced it, the more you will displace it, the greater will be the force and the acceleration acting on that particular mass, and the force and the acceleration will always act towards the equilibrium position. If you displace it downward, okay, you have displaced it downward, but the mass will always try to move upward and reach its equilibrium position, so the force and the acceleration will be towards the equilibrium position. This is how you should be writing these 2 points. Just writing any of them will give you 2 marks because I have written both the scenarios. You can write either of them. Now in the next part it says calculate the maximum velocity of the oscillating mass. We'll have to figure out the maximum velocity of this oscillating mass. So they have asked us about the maximum velocity, and we know there is a formula of maximum velocity. Of a spring mass system. This is the formula. This is the spring mass system. When something oscillates vertically, not about the spring mass system. The thing is, it oscillates vertically. They have said it oscillated vertically, and when a simple harmonic motion is happening vertically, at that time the maximum velocity is calculated using v is equals to a omega sine omega t. This is the formula that we use when something is moving vertically. Okay, when something is moving vertically, so we can say our formula will be v is equals to a omega sine omega t. I hope you guys know all of these formulas. Now the formula will be v is equals to a omega sine omega t, right? V is equals to a omega sine omega t, and we can also say that v max is equals to amplitude into the angular velocity, and from this formula actually this formula has come, which is a omega sine omega t. Okay, now the question arises how we will actually do the math. We know the forces acting on this mass is equals to, there is a spring constant as well, right? The spring has a spring constant, so we can say it has the spring has also extended, and there is also a force acting downward. The only force acting on the spring, the only force that is acting on the spring is the weight of this particular object, right? So this is the only force, and there is the spring constant of this particular spring, as well as there was an extension of 7.5. So we can write F is equals to minus K into del X, right? F is equals to K into del X. We can actually omit that minus part. We can write F is equals to K into del X. So we have to figure out the K. We know the force is the mass, force is the weight actually. So we know the mass was, how much was it? Did they give us the mass? Yes, it was 1.150 into 10 to the power minus 3 divided by the del x, which was 7.5 centimeter, which can be written as 7.5 into 10 to the power minus 2, because it needs to be converted into meter, is equals to the del x. So we'll figure out this del x value. The del x value will be equal to sorry, my bad, we'll be figuring out the K value, my bad. We'll be figuring out the K value, and our K value will be equal to 19.6 Newton per meter. So we have got our K value. As we have got our K value, we can use this K value to figure out our time period, and using the time period we will get our angular velocity, which we can use to figure out the maximum velocity, Now let's do them right here. Let's figure out the time period first. The time period will be, we know time period is equals to 2 pi into root over mass divided by the K. So 2 pi into root over mass will be 150 to 10 to the power minus 3 divided by this k value. The reason behind figuring out the k is this one, 19.6. So basically our time period will be equal to 0.549 seconds. So we have got our time period. Now we can just use this time period to calculate our angular velocity, because this angular velocity is required to figure out the Vmax. So angular velocity will be equal to 2 pi divided by time taken. So it will be 2 pi divided by 0.549 seconds. So it will be equal to 11.4 radian per second. So this is my angular velocity, and now we will just have to know the amplitude, and we know the amplitude is the maximum vertical displacement, which is 3 centimeter. This is the amplitude, right? The maximum vertical displacement. This maximum vertical displacement from the equilibrium position is the amplitude. So we'll just multiply it with this one. So Vmax is equals to 3 into 10 to the power minus 2 multiplied by 11.4, which will give us a value of which will give us a value of 0.34 meter per second. And now the question remains, we have written this formula, but why did we do the math with v is equals to a into w? Where does this particular sine omega t has gone? So basically when it is maximum velocity, at that time this sine omega t is equal to 1. At maximum velocity this sine omega t is equals to 1. So as the question suggests us to figure out the maximum velocity, that's why the formula become a omega, because a omega into 1 is equals to a omega. That's why we have used these formulas to calculate this question. Hopefully you guys have understood this one. Now the next part says explain why maximum velocity of the oscillating mass decreased over time. Why does the maximum velocity decreases? Now this is a very easy and common question. The reason behind this maximum velocity is decreasing is because it is doing work, right? It is doing work. It is doing work when it oscillates. When it is oscillating, it is doing work against the resistive force, right? Let's say if it is going down, when it is going down, there is a resistive force acting in the upward direction, right? Air resistance is acting. So we can say work has been done against the resistive forces. So energy is transferred to the surrounding, right? So we can say work done against resistive forces. So energy is transferred to the surrounding. So basically this is the end of our common questions video. Hopefully you guys have understood each and everything in detail. Now along with this whole video and all these questions, you guys should go through the most recent physics unit 5 papers. Let's say the May 24 paper and October 24 paper. These two papers are actually uploaded. The paper solving videos are uploaded on my YouTube channel. You guys can check those two paper solving videos. I will put the link in the description, and as well as that you guys can also go through the most recent January 2025 physics unit 5 paper solving video of mine as well, which I will upload in within next 3 or 4 hours. So please subscribe to my YouTube channel, and I will actually upload it at least 10 hours before your exam, so don't worry at all. If you are watching the video later on, check my YouTube channel. You will find the Jan 2025 physics unit 5 paper solving video as well. There are some quite difficult questions which you guys should go through in that paper solving walkthrough. So that's it for today. Hopefully see you guys again on any other day. Comment down below if you have liked my videos and it helped you guys. Please comment down below, and see you guys in the next video. Subscribe to my YouTube channel so that you guys more and more videos like this for physics unit 6, chemistry unit 6, biology. We actually post videos for each and every level subjects including economics and business.